Alright, alright. I think we are live. Oh, we're live. Alright, people. Alright, people. For sure. Okay, boys and girls. Okay, boys and girls. Welcome to. Okay, boys and girls. After a lot of wait, after many days, ma'am is live. I can see all your messages. It's not buzzing anymore after a long time. Yeah, give me a confirmation that everything is audible, visible, everything is fine. It's not echoing anymore. I've taken care of it. A very good evening, and like we always welcome you. Welcome to your own Unacademy NEET English channel. I'm Dr. Pankhuri Miglani, your biology educator. It's so lovely to meet you guys. Yes, I know we are meeting after some time. But nevertheless, today's session is going to be as powerful, or maybe more, because today's chapter is rather sensitive. Yes, lot of students, almost everybody has been quite worried about respiration in plants. So, like always, like we did in photosynthesis, we are going to make this chapter super chewable for you, very tasty, okay? And today the kind of notes that I have brought for you, of course I'm going to write each and every word. So pens and paper, people, pens and paper are very important in today's class, because it is by far the most technical chapter of your entire botany. It is even more technical if I compare it with genetics. Okay, so that requires more effort initially, right kind of notes and right kind of pace and the right sequence of understanding respiration is must. But then once you do that, you never forget respiration. And ladies and gentlemen, this chapter has a weightage of 4 questions up until now. You know, I am expecting nothing short of 4 questions in 2024. Yeah, because in plant physiology you see deletion of, and I can't say this enough, transport and mineral nutrition. Everything is fine. Some fire, some heart in the chat box. Botany is happening after a long time. Thank you, Shreya. Vijay, Filhal, good evening. Saw all your messages. Sri Lekha, Laharika, Niveta, audible, visible, everything is fine. Sab perfect hai. Very good. Thank you, Shraddha, darling. Bikram, hi. Please share this session, because this kind of respiration is not done anywhere till now. I've been very sensitive and careful about this chapter because it is rather a difficult chapter. It's not your fault if you find it difficult. So, boys and girls, 4 MCQs accounts for 16 marks. And the way I will do this chapter today, you guys, if you guys give your pure attention, the key word here is pure, then definitely 16 marks are in your pocket, and I promise that you will not even need to revise the chapter after today's class, given, there's a condition to everything, given you sit through the class, okay, taking time out of your precious chatting schedule, take down every word that I'm going to write on this board, okay, and fine tune with me, then definitely you do not even need to revise this chapter before 5th of May. Is that clear? Okay, yeah, so let's begin. today's class. So like I said, respiration and photosynthesis go together. Okay, how much ever tasty the food I have, I could eat the tastiest food in the world, and plant could make the tastiest glucose and sugars in the world. It could be so amazing at photosynthesis like there is no tomorrow. But you know what? In order to run this machinery, the plants and I, we both need energy. We both need energy, and the energy currency, the universal energy currency for any living organisms. And here I mean every living organism here. I'm talking even about prokaryotes, is none other than ATP. Everybody in the chat box right now, give me the full form of ATP. Come on. That's a very, very easy and very, very, you can answer it. Yeah. So today our main aim is to form energy out of the food that we so beautifully manufactured in the class of photosynthesis, which was C6H12O6. Okay, we made glucose, now we want energy out of it. How does that happen? How does that happen? So now what you see is a mitochondria. We call mitochondria as the powerhouse of the cell. But is that it? Yeah. So we are going to understand all of it. How is mitochondria so special? Running by joining hands with chloroplast. Yeah, you make food, I will take out energy and keep this organism, plant, alive. So in today's class, like I tweaked the sequence of topics in photosynthesis for your good. If you remember, we did history of photosynthesis much later at around 12:30 a.m. Yeah, the class went on for some 8 hours, and most of you would have missed the history and factors affecting photosynthesis. If you somehow miss any concept in the class, because the class goes till 12 a.m. or 1 a.m., watch the recorded lecture, but don't miss any topics, because plant physiology is going to give you a lot of questions this year. You don't want to lose those. Now, today again for your good, I have tweaked the sequence a little bit. Yeah, just like how in photosynthesis we did the mechanics of photosynthesis first, that's what we're going to do in respiration. With me everybody, we are going to talk about cellular respiration. Okay, this is different from breathing and respiration that you study in zoology. We are talking about respiration that is happening at the cellular level in each and every cell of the living organism. So first of all, we will introduce this topic to ourselves. Yeah, the introduction. And while I speak about introduction, you know, in nature, when you light a firecracker or you light a candle, energy is released then also. But that is combustion. So while I introduce this topic, na Baba, I am going to talk about respiration versus combustion, right? So when I say respiration at the cellular level, without specially mentioning anything, it everywhere in the world means aerobic respiration. It means that I am using up oxygen and evolving carbon dioxide. Are we very clear? But if I have to mention the other variants, by variant I mean the other processes through which energy can be made in an organism, that would be anaerobic respiration. That is, you know, I don't use oxygen because I don't have oxygen. We will discuss in the later part of the class when and who does that. Today's class is not going to be an 8-hour class. It's a relatively small chapter. Okay, I know I always say that and that the class goes for long. It will be a more or less maximum 4 to 5 hours. Yeah, you know you have to give ma'am a little bit of extra time here and there. But I am aiming not more than 4 hours. Every concept will be so done and dusted that you are going to realize and scream at the top of your voice, oh my God, respiration is so easy. Okay, but again, I need pure attention. We're going to discuss about aerobic respiration. We're going to start with mechanics. I'm very serious about the mechanics because 3 MCQs are going to be from here, if not more. In aerobic respiration, boys and girls, we are going to talk about the steps of aerobic respiration. Okay, that is your glycolysis. Now, you have heard about these terms. Even if I assume you have no idea, Krebs cycle, yeah, that you all are so scared of, and the mighty. Achha, tell me one thing, be very honest. How many of you have never ever understood ETS, of the mitochondrial ETS? I'm not talking about the chloroplast, that I've done, that's done. Yeah, the chemiosmotic hypothesis. But the mitochondrial ETS always gives you the fever. Answers in the chat box, everybody, and be honest. Yeah, get it out of your system. So we are going to talk about the mighty ETC in a very, very different way today. By different, I mean really, really different. You can't miss this. You can't miss this. Then we'll speak about, because the entire song or saga is about producing energy. I want energy. That's the real business happening here. So we are going to speak about energetics of all these steps. All right. How much energy am I gaining in glycolysis? What is happening in Krebs cycle? What is happening in ETC? All right. And then we will talk about the final balance sheet. How much have I made? Either cell. Okay, very important. This is definitely giving you MCQs. There is no year of NEET, AIPMT or any medical entrance exam that has happened in the past, will happen in the future, where balance sheet questions have not been asked. Then comes, we will prove, you and I together, why respiration is called as an amphibolic process, whereas traditionally, if I hear it out, I've been saying, oh, glucose is made in photosynthesis and now I'm going to break it down and get energy. Well, it sounds like respiration is a catabolic process. Then why this? We'll prove it together. Yeah. Then from here you often get ARs. Lot of assertion reason questions. I'm telling you beforehand, even the kind of questions that can be asked from every topic. So you are going to be well informed as far as respiration is concerned in today's class. Again, don't be stingy when it comes to liking the session, saving this session for future use, and sharing it with whoever you know. Then anaerobic respiration, like I said, the variant of giving energy. Now combustion on the other hand cannot be kept in line with something that is happening at the cellular level. Are we aware of this? Combustion is a non-cellular process. Combustion is happening outside. Okay, and then we are going to talk about the respiratory quotient. Just to give you a glimpse what I am talking about in respiratory quotient. Well, you know, I am not eating only glucose all the time. I could be eating fats. My diet, my food, or any organism for that matter, could burn fat, could burn glucose, could burn proteins, organic acids. Let's see what all happens. And that is what respiratory quotient tells us. Everybody is clear? Now let's start. What is respiration? You are more than welcome to write your own definitions that you have learned over the years about what is respiration. But with me, what we do is we arrive at the definition. Now I have been saying that this process is happening in a living cell here. So it is a biochemical reaction. Bio is living, and there are compounds, organic compounds and inorganic substrates also are involved. It's a biochemical reaction, so I need the help of enzymes. Yes? Energy is released here. For photosynthesis, those of you who remember the definition of photosynthesis, we wrote a term endergonic because it required energy. Okay? Here the energy will be released. It's absolutely, in traditional sense, it is absolutely, theoretical sense, it is absolutely reverse. So this is going to be exergonic. Now for this moment, for this very moment, we are going to be very traditional and conventional and keep things simple. Because till now, we haven't proven the fact that respiration is an amphibolic process. So we stick to the tradition of it, that it is a catabolic process. Yes, we are not looking at the gray area. As simple as that. Now, okay, it is happening in the living cell, it is going to use enzymes, it is going to release energy. Yeah, I have a few points in my hand. It is going to break down complex substrates into simple substrates. Once again, when I write or see definition by any author of the definition of respiration, it is automatically presumed that I am talking about oxygen, aerobic respiration. Okay, so if I combine all of this and something else that is special, we arrive at a definition that this is an enzymatic, okay, it is exergonic, catabolic process by which energy is released. Now this is something to be taken care of in multiple steps. Remember, when I spoke about photosynthesis, I told you the equation of photosynthesis looks very straightforward, very plain. But that is just the summary of the process. Our living system is so intelligent, so well designed, that I am not going to release energy. I am not going to burn food off in one go. And we'll see the importance of it. Yeah, we do that in multiple. Yes, we are releasing energy, okay, but in a controlled manner. And that, my dear children, is the essence of cellular respiration, aerobic respiration per se. Okay, so multiple steps, or we write controlled. Now I tell you, this is a very, very important term. You will realize it by midway of the session, pre-break. Multiple steps. Okay, and what else is happening? Process by which energy is released in multiple steps or controlled manner by oxidative breakdown of complex organic substrates into, now once again I am affirming it again and again, I am talking about oxidative. I am talking about the conventional role of oxygen. Okay, so organic substrates into simpler inorganic compounds. Now inorganic molecules rather. Now if you remember, the definition of photosynthesis was exactly opposite here. Yes, no? Remember? 2 weeks back, same place, same person, same time, same channel. Yeah. So there we were making complex substances by uniting the simpler molecules. So remember that equation, and I am going to prove how exactly it is just the opposite by writing the equation. Now what is going to happen is, this is what you got 2 weeks back with me. Yeah, you got this and you got this. Yes, now I am going to do something here to give you 6 CO2 plus 6 H2O and a lot of energy here. Okay, lot of energy. But this equation is happening in a controlled manner. Simply that I am releasing a little bit of energy in one step, then a little bit of energy in another step, then a little bit of energy in the third step. But why? Why am I prolonging it? Okay, like I said, we will see it. The question is, you and I have a very well designed, a very sophisticated system which enables, because clearly there is a gaseous exchange that is happening here. Do you see that? Oxygen has to be in the cell and carbon dioxide will be out of the cell. Yes, we do that all the time. Now for this gaseous exchange, we have the mighty respiratory tract. Oh my God, we sing the song for entire 2 years. Yeah, the whole respiratory, the trachea, the bronchi, the bronchioles, the alveoli, the alveolar membrane, the respiratory exchange membrane, oh, the blood supply, all of that. The oxygen dissociation curve, it's so glamorous. But do plants breathe? Answers in the chat box are always more than welcome. They don't have any sophisticated respiratory system because they're very intelligent. They don't believe in complexities. Yeah, I'm a little biased here. It's my subject. They are mine. I'm botany. So, there is no clear-cut answer. It is, you cannot draw a line saying, no, plants don't breathe. Because breathing, if I'm not wrong, is simply that I am exchanging gases. So the exchange of gas definitely happens, but they do not have organs because every plant part, whether it is, I mean vegetative part, right? Whenever I say plant part, it's a given that it's a vegetative part, root, stem and leaf. Yeah. So root, stem and leaf, all of them have their own contact with the air. For me, in my body, if I want to respire, if I want exchange of gases, well, I will have to breathe through the nose. I will have to enter through the tracheal system, through the respiratory system. Yeah, my other systems, my heart cannot suddenly get oxygen on its own. My excretory system cannot get oxygen on its own. It has to be through the respiratory system. But in plants, what is happening is the stomata in leaves, yeah, lenticels in stem and epiblemal cells in root. These three structures are always in contact with the environment. So if you ask me, the exchange of gases is happening here, but I don't need the transport of gases through a long distance. My respiratory system, our respiratory system, has to transport the gases to mighty excretory system, to the entire body, to the heart, and the nervous system is like, give me oxygen, alright? But here, it is happening quite independently and it is happening over a very short distance. So they never cared about developing a respiratory system. They kept it simple. The exchange is happening with the environment and intracellular spaces. So here, these are nothing but the intercellular spaces. Intercellular spaces. Yes, no, kind of makes sense to everybody. Yes, but in animals, in us, it is a little complex. You know why? Because the exchange is happening. Exchange. Again, I'm talking about breathing. I'm not talking about cellular respiration. Okay? Exchange between environment and where are the gases going here? ECF. What is ECF? Chat box means it should be completely, let me see what you guys are doing. It should be so thoroughly filled with the answers. Guys, I'll tell you one thing. There is an enlightening piece of information that I'm going to give you today. Saucy, You played it fine. So I'm going to give you a very, very enlightening piece of information today, yeah? Always check the volume level of your own device when you're attending any class in the world. Any class. Whether it's on Earth, Mars, Pluto, Moon, wherever you are. Make it a point that you check the volume level of your device. It really, really makes a big change in the life. Okay? क्लास 10th वाले भी देख सकते हैं ये लेक्चर, डेफिनेटली उन्हीं के लिए ही है. The sooner you get right piece of information, better it is. Alright, so boys and girls, good piece of information. Endgame classes, botany classes, you must have checked your dashboard. They are scheduled from tomorrow 4:05 p.m. We are starting a new chapter, sexual reproduction in flowering plants. Very, very, very important chapter. Yeah, gives you around 4 to 5 MCQs. We are going to do it in the Endgame batch. Let me tell you, for new people, Endgame 2 batch is running. You can still join the batch. But don't make it too late, because then you are missing out on these lectures, and then you will have to watch the recorded lectures, which is not really fun. Yeah, so attend the classes, morphology, biological classification, everything is already done. There I go. Okay, so Endgame 2.0 link is given in the description box, and I think it is pinned in the comment section. You can always click on that link and enroll in this batch before it's too late. I'm telling you, it'll be too late if you keep missing the chapters. In all the subjects, classes happen every day. Yeah, 6 teachers, all the amazing teachers are teaching you, and it's going quite intense. Every Sunday, these guys are rogered with the latest pattern based MCQs and tests. Ask anybody who would like to give a feedback. Endgame students, give me a shout out, yaar. Come on, give me a shout out. Give me a very nice shout out. So you can still join this batch. The link is given in the description box, but don't forget to use the code PM1Live when you enroll into the batch. Yeah, you download the Unacademy app. Yes, you will find the link. When you go to the link, it will automatically take you to the platform. If you use this code, then only you get the discounted price. You don't want to pay the full price, isn't it? Good. And one more thing here, I forgot. The scholarship test. That link is also given in the description box. The description box is a very powerful place to be in. So on February 11th, can you see the details? Guys, this batch is really beneficial for your preps. Boosts up a lot. Thank you, darling. Don't regret after NEET. Yes, this batch is the only pure English crash course. Not crash course. We are doing things from the scratch. Absolute basics. I'm giving my handwritten notes, questions and whatnot. And then you get to meet the teachers in a controlled platform. It's not YouTube and it's not one shot. Okay. So, I've already told you the advantages of doing detailed lectures. Plus you get tests and MCQs every Sunday. Test practice is very important, otherwise there's no selection. There is no selection. So if you haven't joined the batch, join it. And the scholarship test can give you scholarship up to 90%. You can win laptops to do more chatting, mobile phones to take more pictures, and other exciting rewards. Chance to get one-to-one mentorship with your favorite educators. Any favorite educators on Unacademy platform. Yeah, you get a smartwatch also. I want a smartwatch. Yeah, I don't miss the scholarship test. Enroll right now. Come on, you have to here. Chalo, let's go back to what I was saying, because that is actually going to get you selected. Let's solve a question. How about solving a question, everybody? Can you see the question? Now you can. Respiration is breaking of, I'll move. Otherwise you guys will start screaming, ma'am move, ma'am move. Come on. Everybody means everybody. Answers in the chat box like there's no tomorrow. I can see each and every message. Everybody is sure? The answer is 3. Let me read. What is respiration? It is a core question, absolute basics. Breaking of a type of bonds like ionic or non-ionic of complex compounds through oxidation within the cell by utilizing. That is where you get a, you get frowned by what has been said. Breaking of CC bonds of simple molecules through hydrolysis. Hydrolysis is not happening. Breaking of CC bonds, carbon bonds of complex molecules through oxidation within the cell to release considerable amount of energy. Yes, this makes sense to me. We just defined it. Breaking of carbon bonds of complex molecules through hydrolysis. Again, hydrolysis is not happening. Easy? Easy means easy. Now, what is combustion? Combustion is you burn something, okay, in the air. Oxygen is used and some amount of energy is released then and there. It is not happening in a multi-step process. But what is the difference? This is just one difference. What is the difference otherwise between combustion and respiration? Answers in the chat box. I am reading all the messages. Now I am going to create a twist here. First I am going to talk about the similarities. Before verses, let's talk about similarities. Yeah, nobody talks about similarities between respiration and combustion. Everybody is like, how are they different? What if the examiner gets innovative that day and he's like, okay, which of the following points describe the similarities between respiration and combustion? Any guesses? Well, in both the cases, there is breakdown. There is breakdown of complex organic substrates. Complex organic substrates. Yes, no, do you agree? In both the processes, energy is released here. Energy is released. In both the processes, I am using oxygen. I am using oxygen. Oxygen is utilized in both the processes. Yes? Yeah? And in both the processes, there is very, very important evolution of carbon dioxide and water. Of course, the amount of energy released in this case is much less. And we come to writing the differences now. Let's write the differences, everybody. So when we write the differences, on one side, this will give you a multi-statement question. Don't say later, I didn't know. It's very easy yet painful to say after the exam that I didn't know, because you have been told, you are being informed. I am doing absolute ABC of the chapter. Yeah, like I claimed, the only notes that you will get. And combustion. Now differences in the chat box, come on, for yourself. First thing, this is happening in the living cells here. This is happening in the living cells. It's a cellular phenomenon. You and I cannot be alive without this. This is a non-cellular phenomenon. Non-cellular phenomenon. You light a candle. You light a candle. Then what happens? If it is a living or cellular phenomenon, I would require enzymes. Yes? So this is enzymatic, or in other words, this is a biochemical reaction. This is a biochemical reaction. Tell me in the chat box, what will you call this? This is a physicochemical reaction. Physicochemical reaction, because it is not happening in the living cell. So I don't require enzymes, do I? Do I? Tell me if I'm wrong. Then the biggest difference which has been asked in previous years, and I am putting a star on this. There is controlled release of energy here. That makes cellular, controlled release of energy. That makes cellular respiration very, very awesome in our body. And here there is one step release of energy. Are we together? This is often the examiner's point of framing a question. Now, more than 50% of energy that your cell makes during respiration is lost as heat. That is how I am able to maintain my body temperature. Otherwise, that's going for a 6. Okay? So, more than 50% of energy is lost as heat. And rest 50, around 45% of energy is what I use for my metabolic activities, for the growth, for the repair, to be alive, to be taking this class, as heat. Remember that? We will follow the laws of thermodynamics. Wherever we go, laws of thermodynamics are being followed. And here, no release of energy. Yeah, the entire energy is lost as heat. You want to use it? You will have to apply an apparatus to use it. Do you all agree? This is just the teeny tiny basics of respiration which even a 10th class student would know. I haven't gone to the mechanics yet. I'm still introducing. Let's solve this question. I will move out of the way. Come on. Let's solve this question, everybody. Come on. Answers in the chat box. Mayuk has answered. Thank you, Prashant. Lots of love from Bangalore. Okay, I will correct it, Shreya. Ye lo. This is what you want me to write. Ye lo. Happy? Now, people are saying 3 also. Are you sure? The plants do not breathe. Can be justified. Read the question carefully. This is from your lines of NCERT. The very second topic in NCERT is, do plants breathe? Open up your NCERTs. Tell me the page number where it's given. The new NCERT. So much of noise being produced for new NCERT. The plants do not breathe can be justified, except you have to tell the point which is not making sense. Plants do not have sophisticated organs for gaseous exchange. Yeah? Each plant part takes care of its own gas exchange needs. This is also true. First one is also true. We just spoke about it a few moments ago. There is huge transport of gases from one plant part to another is absolutely wrong. There is very minimal transport of gases from one plant part to another. There are no long distance transport of gases. Okay, there is translocation of water and minerals that happens through xylem. There is translocation of sugars that happens through phloem. We good? We good? Think about it. Yeah, common sense. Best friend. Yeah, very nice. Leaves are doing photosynthesis. Now listen to me, this is not given in the textbook because most of you have answered 4th. Okay, clearly tells me that there is a lack of common sense in the country. Leaves are the site of photosynthesis. They have the chlorophyll. They have the stomata. They open this stomata. Isn't it? They get the carbon dioxide. 8-hour class 2 weeks back was all about that. and give us oxygen which is released through the stomata. Why do I need long distance transport of gases here? Think about it. Give yourself a knock on the head. All of you who answered fourth. Root, stem and leaves respired at rates far lower than animals. Come on, you guys know the respiratory rates in your own body. You study that in zoology. Do you think the respiratory rate of plant body will be as much as your respiratory rate or higher than that? Not cool at all if you answered it incorrectly. Okay, now we talk about the aerobic respiration. This is the time that I want everybody to open their notebooks, get the pens into the right place and start writing. Now, the steps of aerobic respiration, the first one is glycolysis, isn't it? The very first one and rather the universal process is the glycolysis. Then what happens? Krebs cycle will happen. Krebs cycle will happen. Okay? Yeah, in your NCERT, after glycolysis, NCERT puts the topic as aerobic respiration. I have tweaked it. And then what happens is ETC, but I am going to tweak it further. My wish. I am going to call it terminal oxidation. I am sure you haven't heard much about this term, but today we are going to make sense out of this. Alright. So these are the 3 steps, boys and girls, of aerobic respiration. Now before you jump on the glycolysis part, because you are aware of the fact that glycolysis is a universal process and happens in anaerobic organisms as well, you are right. Okay? But we will deal with that separately. We are going to talk about the conventional aerobic respiration. Let's together write the site. Now answers in the chat box. Chat box should be filled with, start making sense in the chat box. Yeah, enough of playful. What is wrong with you guys here? Oh, you're crying for answering wrong. Oh, you should. Thank you, Saucy. Cytoplasm, very good. Cytoplasm. Now, ladies and gentlemen, cytoplasm is present in every organism here. Talk about a monodron, talk about a simple bacteria. I have cytoplasm. Yes. Krebs cycle, what is the site? Everybody. Mitochondrial matrix. Mitochondrial matrix. The powerhouse. And what is the site of terminal oxidation? Quickly. Real sense in the chat box. No playing around. Enough. Inner mitochondrial membrane. Inner mitochondrial membrane. Yes, no? Makes sense? Okay. Now we are going to start with the very first process, which is glycolysis. Are you ready? What is glycolysis? We are going to introduce ourselves to the process of glycolysis. First of all, it is also called as the EMP pathway. Answers in the chat box. What do you understand by E and M and P? The credit has been given. Now, whenever you study a biochemical reaction, it starts with a ritual. And the ritual is to credit the people who discovered the biochemical reaction, because think about it. You think that this particular cycle or pathway is so complex, I can't study, I can't solve questions out of it. Think about the people who actually dedicated their life into discovering the pathway, and it didn't happen in a day. Alright. So it is Emden, Meyerhoff and Parnas pathway. Good. They discovered the cycle. What is the site of glycolysis is my concern. You said it is cytoplasm. Thank you very much. You also said that if it is happening in the cytoplasm, it is a universal or popularly called as the common pathway. Now, why do I call it common pathway? We are introducing ourselves to the process because this is the pathway happening in aerobic as well as anaerobic organisms. Makes sense to us, everybody? Yes? It consists of 10 steps, boys and girls. Kindly don't skip any step. These are mandatory 10 steps. Now the real deal. What is actually happening here? What is happening in glycolysis? Well, if I want to know what is happening, let me get back to the term itself. Yeah, glyco here is glucose and lysis is breakdown. If it is glucose breakdown, then yeah, it's done. Why can't we do it in just glycolysis? Yeah, so the very first point to be noted, running parallelly with the concept that it's a controlled release of energy, in glycolysis we will do partial, keyword people, keyword very very important, partial breakdown. I did not say oxidation. Kindly don't be very liberal with these terms when you study respiration. This chapter is a lot about terminology as well, and you will realize this midway today around 6:30 or 7 p.m. Okay, so partial breakdown, because oxygen is not used in this process. This process is independent of availability of oxygen, of glucose into pyruvic acid. And who will tell me what else is made? What else is made and how many molecules of pyruvic acid are made? You had glucose, which is a hexose sugar, 6 carbon compound. You will always balance the number of carbons in a biochemical process. It's not your wish or my wish. So I need to make 2 molecules of pyruvic acid come what may. 2 molecules of pyruvic acid. I've deliberately written it this way. Always know your destination when you are studying a biochemical process, so that you don't leave in between. Your destination or your aim is to get 2 molecules of pyruvic acid, and as the promise is of respiration, whenever any step of respiration will happen, I repeat, any step of respiration will happen, some amount of energy will be formed. Is that clear? I am not saying how much of energy will be formed, but it will be formed. This energy, can you guys be wise and make my evening more beautiful by telling me the forms of energy? I am running very basic right now, but I am also expecting somewhere that you know what form of energy is formed. While you do that, I will divide the 10 steps into 2 phases. Okay, how many phases? 2 phases. The first phase is called the preparatory phase. And the second phase is the payoff phase of glycolysis. Happy? Yes? Preparatory and payoff phase. Okay, so you're right. It is ATP. Ooh, ATP is what we are looking for. And it starts forming in the first step itself. And I also get NADH2. Now boys and girls, in this chapter, in this concept, in cellular respiration, mind you, whether you're studying from me or somebody else, NADH2 is the hero of the story. He's the lead actor. Well, we thought ATP would be. ATP is just the guest appearance. But the most awaited guy. Okay. So, out of these 10 steps, 5 steps are preparatory. Hey, there's a difference between process, pathway, process and pathway, okay? steps and process are two different things. You know that, right? English, normal English. Now, payoff is again 5 steps. So, a process or pathway could be divided into multiple steps. Are we ready, everybody? Yes? Now we get to the exact pathway. How many points did we write? 1, 2, 3, 4, 5, 6. We wrote 6 points. Chalo, let's start the pathway itself. So, we are assuming, because this is the most favored substrate, we are assuming that I made glucose in the last class and I am going to start with glucose as my substrate. There I go. I have glucose. Is that clear? Now, in plants, there was a time not long ago when we used to study transport, and in that chapter there was a song that I used to sing all the time, and it was one of my favorite questions. On YouTube you would find a short where I have spoken about this. Not on this channel though. Always remember, and it can still be asked, that plant synthesizes food in the form of glucose. Repeat after me. It forms, the result of photosynthesis could be glucose, but the plant stores food in the form of starch. So when glycolysis happens, I am not getting glucose. It's not like I just did photosynthesis and then the very next moment it could happen. Yes, that is possible. But if the plant is picking up starch, then it will be hydrolyzed. Yes, I will use the amylase enzyme, convert it into maltose. You know the chemistry of it. I don't have to tell you the biochemistry of it. Suit yourself. Okay. Or the third thing, like I was saying in transport, whenever the plant translocates sugars, or in simpler terms, the transport of food happens in the form of sucrose. That will also be broken down. What will you form? If you break down sucrose, you will get glucose and fructose with the help of invertase enzyme. Am I right? That's your chemistry. I won't know. Okay. So, even if it is sucrose, then also I will turn myself into glucose. And the very first step of this cycle is that glucose will be activated. Glucose, this is called activation of glucose, wherein I convert glucose into glucose 6-phosphate. Now boys and girls, I want you to write this cycle very neatly. I have less space. You turn your notebook, your notes, your page horizontally, landscape mode. And I want you to write in an absolute straight line, very, very neatly. That matters. This is called as the phosphorylation or activation of glucose. Activation or phosphorylation. What is phosphorylation here? Phosphorylation of glucose, because I am adding at the 6th carbon, I am adding a phosphate group. Yes. Now where do I add it from? I need a phosphate group. The cell is like, I don't like glucose. Give me something more. Yeah. So I take the help of what I always have in my cell, that is ATP. Okay. I take the help of ATP. So instead of forming energy, you have ended up using energy here. You use ATP and you form ADP plus inorganic phosphate. Not cool at all, but that's what happens. Now the enzyme that is taking part here is very, very important question. It was asked in NEET 2022. Most of you think, ma'am, enzyme, we don't have to do, it's not given in NCERT. Go to the text of NCERT, please. It is mentioned hexokinase. Glucose 6-phosphate is going to isomerize itself. Alright, I am going to create an isomer. What is an isomer? What is an isomer? The structure is different. Chemical formula is same, and form it and change it into fructose 6-phosphate. Well, if you get fructose, here if you get fructose, because I was getting fructose, then it will directly enter the glycolysis and form fructose 6-phosphate. This is simply the isomerization here. So would I require any energy? Not at all. I don't require energy. Isomerization. Isomerization. And what will be the enzyme? Yeah, enzyme at this level is not very important. I agree. I'm not going to trouble you. But common sense, like I said, is so beautiful to use. You can say isomerase. Isomerase enzyme will be used. Okay, the general group. Then fructose 6-phosphate gets really serious in life. The cell says, you know, I don't want this. I don't want fructose 6-phosphate. Give me something heavier to work with. And then only I would form energy. Because till now, you will see in the next step, I would form fructose, further phosphorylation, very, very important. We are at the third step. Further phosphorylation happens and I form fructose 1,6-bisphosphate or biphosphate, however you like to call it, your choice. Yeah, once again, phosphorylation has happened. Okay, ma'am. So now on first and sixth carbon, both I have the phosphate group. Earlier, I had the phosphate group at the sixth, inorganic phosphate at the sixth carbon. Now once again, the cell is not listening to us. The cell is saying, I need additional phosphate group, give me a heavier compound, heavier substrate to work with. So I request the ATP once again. Okay, and this is not good. I am again breaking down my energy and I am using 1 ATP. Is that very clear? This is the third step. Now suddenly the cell realizes that, oh God, this is too heavy a substrate to deal with. Break it down. Okay, break it down. So now this complex molecule will break itself into two parts. And while I do that, tell me in the chat box how many carbon atoms are present in fructose 6,1,6-bisphosphate. Quickly in the chat box, everybody. Yeah, you started with 6, you are at 6, you are at 6, you are still at 6. But now the cell is like, my God, fructose 1,6-bisphosphate is too heavy to work with. So I use an enzyme called as aldolase and break this compound into a ketone and an ketone and aldehyde. Okay, so I form dihydroxy acetone 3-phosphate, lovingly called as DHAP. Yes, and it remains in equilibrium, okay, in equilibrium with the aldehyde, which you are very, very familiar with. It gives me a lot of happiness to even name. Yeah, glyceraldehyde if you remember from photosynthesis class, I told you this compound is hero of the photosynthesis as well as respiration. If you remember, I'll show you the steps. Glyceraldehyde 3-phosphate. What is the loving name of this compound? Everybody in the chat box, we called it 3-PGAL. So I have 3 and 3 and they are both isomers. Yeah. They both, one is ketone, one is aldehyde. Chemical formula is different. So I say that the enzyme is triose phosphate. Ma'am, we don't want to learn the enzymes. So it's better to do more than to regret later. Is this clear? Is this very clear? Now the cell is like, you know what? Cytoplasm has been listening to me since some times. I said, give me a heavy compound, fructose 1,6-bisphosphate, I got it. Then I said, break it down, it broke down. But now, do I include both the compounds in my further processes? Yeah? Or I include one of them? If I include both the ketone and aldehyde, I will have to run parallel processes. But if I run only one guy here, then it's going to be easy. Now, if you remember in photosynthesis, do I have it? Yeah, that's me. Haha. If you remember from photosynthesis, before this happens, NCERT writes triose phosphate and I decoded it for you. Isn't it? That triose phosphate which is going to form fats, which is going to form sugars, which is going to do everything. The reduction happened in the reduction step where energy was utilized, ATP and NADH2 were utilized and triose phosphate was formed, and this triose phosphate, remember, we had to run 6 cycles because triose phosphate, poor guy, PGAL had to regenerate ribulose 1,5-bisphosphate, RUBP, and he had to make glucose also. How many of you remember that? It is from this birth only, just 2 weeks back. So these 5 steps that you see in front of you, yeah, till glyceraldehyde 3-phosphate, which is going to lead the reactions or lead the payoff phase, are called as the preparatory phase, everybody. If you are writing, write it here in bold letters because you will remember it that way. Preparatory phase. I have prepared the glucose molecule to now give me some energy. Are we good? Do you remember? Now let me show you the reaction I was talking about. You remember? Phosphoglyceric acid, the first stable compound, Kelvin cycle. Yeah, this class happened, the date is there. No, photosynthesis class happened, you can go to the playlist and check. 1,3-bisphosphoglyceric acid, although it's not given in NCERT, but I told you. That time, if you remember, I called this step as reduction or glycolytic reversal, and I categorically mentioned that you will see the exact reversal of this reaction in, have a look, have a careful look, okay, I'll move out of the way, in respiration. Do you remember that? So that's what you are going to see now. You are going to see the formation of 1,3-bisphosphoglyceric acid. Okay, here I was making, where my head is, big head, I am making from phosphoglyceric acid aldehyde, and I used ATP and NADH2. What am I trying to tell you? I am trying to give you a hint here. I am trying to give you a fair hint that if I use energy in photosynthesis, now is the time that I get energy. So let's get going with the first compound here. And who is the compound? Now we can write easily in short form. We can write 3-PGAL. Now this guy is going to, but tell me one thing. I started with a hexose sugar. I cannot create a disbalance. So 2 molecules will take part. Yes, because this is a 3 carbon compound, we just ascertained that. So 2, everything in the payoff phase will be into 2. Is that clear? Now 1,3 bisphosphoglyceric acid, exact reversal of what we just saw with my head on the screen. 1,3 bisphosphoglyceric acid or glycerate will be formed. Do you see what all has happened? Eyes on the screen, not on me. Not only have I converted aldehyde into organic acid, I have also added an extra phosphate group at the first position. So, some of you might assume that this phosphate group again I'll have to take from ATP, but that's not the case. Here, this used to be a very popular question when I sat for the exam many years back. Here the source of phosphate is phosphoric acid. One of my favorite questions, if you ask me, because a lot of people can go for negative marking here. I will use phosphoric acid and I will add a phosphate group at the first position. So ladies and gentlemen, definitely phosphorylation has happened. But at the same time, this aldehyde or this substrate is getting oxidized to form an organic acid. You know that, chemistry tells you. So now I will get the reducing power. This will be taken up by NAD+. The hero is here on the screen. So I call it oxidative phosphorylation. What has happened? Oxidation has happened and phosphorylation has happened. Now what I'm going to do is, I'm not going to stop here. The cell is like, yay, I'm going to form energy now. Yeah? And it is going to form, very simple, this is the simplest step of glycolysis. 3-phosphoglyceric acid. What has happened? I have removed the phosphate group that I took from phosphoric acid, not ATP. Kindly don't assume. And that will be taken up. Now is the time. Now is the time that I pay off for what I did. What wrong did I do? I said respiration is going to give me energy and I use energy in the preparatory phase. Now is the time to pay for that. So now I am going to make ATP. Okay, from ADP. From ADP, and I am going to take the phosphate group from the first position. Is that clear to everybody? This is called as one of the most important questions of your entire process. This is called as substrate level phosphorylation. I told you in photosynthesis that phosphorylation has many variants. You will get to hear about oxidative phosphorylation, you will get to hear photophosphorylation, which is happening in the presence of light, and substrate level phosphorylation is the key term for respiration. When with a substrate, with the help of a certain substrate, I acquire ATP, I form ATP, it is called SLP. Now SLP is not an official term, I am just introducing that so that we can use the short form later. Now life is very easy. What I am going to do is, I am going to convert 3-phosphoglyceric acid into phosphoenol pyruvate. I am going to make an ester. I am going to make an ester out of it. Yes, this simply happens with the dehydration and the enzyme enolase. Yes, and the enzyme enolase. So this is a simple dehydration. But things get serious in the last step here. The 10th step where I reach where I wanted to, that is pyruvic acid. Hold your guns, a lot is remaining. Just understand the flow of the pathway. What has happened? Eyes on the screen. Phosphoenol pyruvate has changed into pyruvate. Again, if you speak the flow, if you analyze the flow of the pathway, just the tonation of the substrate will tell you that phosphate group has been removed. Once again, I am going to form ATP. I love making ATP. Now to me, what seems ADP was sitting in the cytoplasm, it took the phosphate and changed into ATP. Once again, my favorite question, where is substrate level phosphorylation happening in the cell? Substrate. Whenever ATP is formed, I go red. Substrate level phosphorylation. Is that okay? Guys, please write this pathway nicely in your notebooks. Now, eyes on the screen. I started with 2 molecules. Now, what really seems like happening is, hey, I use 2 ATP. I use 2 ATP molecule in the preparatory phase, and I am using 2 in the payoff phase. This is the mighty payoff phase. So, it's null. We always talk about the net formation, the net gain of energy. First thing first. But you're wrong if you're thinking that. Because I started with 2 molecules and I said it, that whatever will happen in the payoff phase will be 2 in number. So, this is 2. This is also 2. This is also into 2. This is also 2. This is also into 2. This is also 2. This is also 2. And this, ladies and gentlemen, is also 2. And that's what I promised for. That 2 molecules of pyruvic acid will be formed. Okay. So now if you look at the energetics, I'm not going to take any time and directly get on to the energetics of glycolysis, because that is where you guys get confused. So let's talk business. Kitna paisa kama? Energetics. Energetics, whatever step it is, we talk about the net gain. Okay, net gain. So I see that 2 ATP are consumed. Tell me the steps here. They directly ask the steps. At the first and third step, what are the first and third step? Whenever you are adding the phosphate group. First was glucose into glucose 6-phosphate, speak after me. Then fructose 6-phosphate to fructose 1,6-bisphosphate. First and third step, you consume 2 ATPs, okay, and you formed 4 ATPs produced. I formed more, thank God, okay, and you also formed 2 NADH2. Tell me the step, one of my favorite steps at least, that is the 6th step, wherein you converted, which was the exact reversal of what happened in the reduction in photosynthesis. Wow, that's so nice to relate 2 topics. Yeah, not so for us, ma'am. Good for you. So, on the 6th step, when you are changing aldehyde into the organic acid, once again, you're getting 2 NADH2. Now, talk about the net gain, always and always. The net gain, very, very, very important question. There is no algorithm required. Net gain is of 2 ATP and 2 NADH2. Okay, and I get 2 molecules of pyruvic acid. That is where glycolysis happens. Any problems so far? Are you good? Now, guys, in this chapter, I must inform you. Now, some of you had texted me. And by the way, in the past 1 week, I have not replied to your texts. Very, very important announcement. It does not mean that ma'am is angry at you, ma'am doesn't want to answer you, you did something wrong. Huh? No need to get into the negative zone. Alright? But I did receive certain texts and I've been looking at all the texts. I would never ever miss a single text. Okay? I sleep with those concerns and I get up with those concerns. Always. Many videos have been doing the rounds on YouTube. I haven't had the time to watch them. About new NCERT saying something in photosynthesis and respiration and old NCERT saying something and the concept being different. Today I am going to clear all those concerns and doubts once for all. Okay, so those of you who messaged me, I did not reply because I had to address it. Some of the people have said we'll do it on 6th or 7th. Is that clear? So now the problem is NCERT says something in the text and misses it in the diagram, in the image, or says something in the image and says something else in the text. I'll show you today. What do? Your concern is valid. But then NCERT is NCERT, right? NCERT does that. It's a habit. Okay? And that is why I am here for. If you want to study every day, interact with me daily on the app, in the platform, in a regulated class, you should join the Endgame 2.0 batch. Link is given in the description box. Use the code PM1Live. And I hope that you don't watch recorded lectures by delaying your admission in this batch. It is essential in the last lap of your preparation to associate live with the teacher that you like studying from. Is that clear? Glycolysis is done. Ma'am, why there is no 2 what? 2 phosphoglycerate formation in between 3 phosphoglyceric acid. Oh, such a cute question, Varshini. Well, darling, I think if you're converting 3 into 2, yeah, you're just changing the conformation, you're just making an isomer and it is not really giving you any energy. And I think chemically it is possible. It is easy to just cause esterification. That's a lot of chemistry. Where is it coming from? To just change 3 phosphoglyceric acid, bachao, into phosphoenol pyruvate. Don't laugh. Okay. Bikram, thank you so much. Please join the Endgame batch here. It's at the minimal price now. Unacademy has never introduced a batch at such a low price. Laharika, what are you saying? What happened in mitochondria? Sunlight is saying, ma'am, please don't use red color. It is not visible. So then I won't have color. There's so much to do. Examiner's favorite. Oh, Chat GPT is in the class. Vachan, what a beautiful name you have. After long time to you, class. Thank you. Can you please increase the volume? Yeah, that's what I said. Looking for relevant. I watched your Plant Kingdom for the first time and trust me, you really meant what it is like never before. Thank you so much. God bless you. That's what we are here for. ठीक है. Awesome. 2025 के लिए best course है. Okay, Mayuk. Okay, Shraddha. Thank you for your valuable suggestions. It's not making sense. Chalo, let's go further. What we are going to do is, whenever we study a biological process, ma'am is going to decode NCERT image. Yes? Let's do this. Now, NCERT says, as she is, okay, start from glucose, It's a 6-carbon compound. It's a hexose sugar converted into glucose 6-phosphate. Answers in the chat box. What do you call this step as? What is the glamorous term that we gave it today? This is the activation, and you can add, you can add hexokinase, because if you read the text, and you are going to thank me on 5th of May, later, maybe earlier, maybe today itself, in the text she has mentioned hexokinase. That's how NCERT is. Glucose 6-phosphate is changed into its isomeric form, so Varshini will not use any energy. Fructose 6-phosphate. Now the cell is like, give me a more, add some vanity, yeah, add some phosphate group. I use 1 ATP. I use 1 ATP. Yeah, please be very clear about how many ATP you are using. Fructose 1,6-bisphosphate changes into the triose phosphate. See, in the text she will write that it will change into DHAP and glyceraldehyde 3-phosphate. But in the image, she is like, triose phosphate, glyceraldehyde 3-phosphate. Oh, it's written, my bad. Dihydroxy acetone phosphate. Oh, new NCERT is pretty cool. So, DHAP is formed and they will remain in equilibrium in the system. But this guy goes further, takes the lead. Okay. Now, do you see everything is into 2? Everything is into 2. Everything is into 2. Everything is into 2. I end at into 2. Okay. So, let's do into 2 here as well, because we are very much worried about how much energy is formed, like I said earlier. And here also into 2. Okay. So, 4 ATP are formed, but net gain will include the subtraction of 2 ATP, and hence I get 2 ATP. All good in my life. Yes, 2 molecules of pyruvic acid are formed, and needless to, this also. So, 2 NADH2 are also formed. Very, very important. Where are they lying? This energy, I am very happy to make energy. I am very happy to make pyruvic acid. But all of this is still present in the cytoplasm. Now, pyruvic acid, since we are talking about aerobic respiration, will enter mitochondria. If it is anaerobic respiration, which we will speak about post break in the later part of the class, it will not enter mitochondria. Okay. So, before that, let's solve this question. I will move away. Let's do this. Answers in the chat box. NEET 2019 year. It's a recent question. Previous year questions are very important. Done? Everybody? Conversion of glucose to glucose 6-phosphate. The first irreversible reaction. Do you see? Do you see? Of glycolysis is catalyzed by. Once you have activated glucose, you cannot go back to being glucose. See, if you were thinking ma'am is telling us anything extra, I would always go a notch higher because I want you guys to be safe on the D-Day. Can you blame me for that? Little bit extra we can do, all of you agree? Or you don't want me to do anything extra? Now, this pyruvic acid, since we've been specifically speaking about, okay, still there is a question. I just have this habit of putting a lot of PYQs here. 2023, boys and girls, which is just the year that just passed away. So, it is quite probable that this concept can be repeated. Mind you, it is essential to do PYQs, very, very essential. How much ever theory you read from whoever, from whichever teacher, if you are not solving PYQs, you are going nowhere. I said nowhere. Mind it. You guys are scared of assertion and reason, and that is what I've put in the class. Answers means answers, everybody. Assertion says ATP is used at 2 steps in glycolysis. Read these steps. See, whenever photosynthesis and respiration are concerned, why people lose marks in these chapters? Point number 1. They are not familiar with the terminologies involved in the cycles and pathways. Point number 2. When they read the question, it's rather a skill how you approach the question or read the question. They are not catching the keywords. The examiner is on your side. He is always giving you the keywords. He is always hinting at the answer. Okay. So, learn to read the question whenever the chapter is super technical, and I mean about genetics as well. It is about how you read the question. And you will learn how to read the question only when you solve the questions. It's as simple as that. Okay, if I tell you in theory, this is how you read the question, this is how you drive the car, this is how you swim. You can hear the theory 118 times, chant it every day, but till you swim, till you drive the car, till you solve the question, things are not happening. Okay, I can't say more than this. So, ATP is used at 2 steps in glycolysis. There we had the keyword. Now, somebody could just read it like this. ATP is used at 2 steps in glycolysis. Okay, first step is used. First of all, you are going to take a lot more time in solving the question if your eye is not catching at the keyword. And secondly, your accuracy will be reduced. You will mostly go wrong in super technical concepts and chapters. So, like I have taught you, how do you solve an assertion reason question? My regular students know this. I have given you the trick n number of times. ATP is used, oh, it's talking about the preparatory phase, at 2 steps in glycolysis because first ATP is used in converting glucose into glucose 6-phosphate, and second ATP is used in conversion of fructose 6-phosphate into fructose. Yeah, that's making sense. So, this is ruled out. Both A and R true, and R is the correct explanation. Absolutely right. R is not the, this is also ruled out. False is also ruled out. Very good. You guys are amazing. Okay. Now, since rest of the 2 steps, what are the 2 steps remaining in aerobic respiration? Congratulations for completing glycolysis, the very first step. Yeah, it happened in a jiffy. This is a very short, easy chapter here. I'm going to finish it very soon. Today's class is not going to be an 8-hour, 10-hour class, I promise you. It's going to be a cute little sweet chapter, but intense, requires more attention from your side. Yeah. So, what we'll do is we will draw the mitochondria, which you do in the chapter of cellular structure, cell structure, but to keep the class wholesome and safe, yeah, I am going to draw mitochondria. Are you guys ready? Yeah, let's do the mitochondria. When we do the mitochondria, let's do mitochondria together, just how I drew the chloroplast. So, what am I making, guys? What did I just do? The Picasso moment. Of course, it's a disc shaped. Actually, mitochondria has many shapes in other organisms, but since we are talking about higher plants, what did I just make? Well, I am starting from inside to outside. And what am I making, guys? Could you make sense out of this? Now, this is done in 8th standard. No, they don't, they do have cell, right? When they're babies. I think I made too much of folding. I folded the entire membrane here. And mighty, mighty, what did I just draw? Yes? Make sense? So, you guys have answered it quite correctly. This is the matrix akin to cytoplasm of the cell. Okay, what am I drawing now, which is very peculiar about this organelle? Yeah, and very, very peculiar. What is this, everybody? And in the matrix, I have the enzymes as well. Enzymes are what? Keep answering in the chat box here. I don't think you need to draw mitochondria, do you? Now, let's label the parts. Should we label the parts? The first one is the outer membrane, which will have the porins, just like chloroplast. It's a double membrane, double enveloped organelle. This highly folded structure is the inner membrane. Inner membrane. Happy? Easy? Just like we had periplastidial space, which prevents the collapse of the organelle, here also very, very important here. We have the perimitochondrial space. Perimitochondrial space. Everything is visible to you? Now, some authors could just call it, which is not charming enough, as the intermembrane space. Intermembrane space is a generic term, yaar. Now, we guys are NEET aspirants, might as well act like it. Periplastidial space in case of chloroplast, because chloroplast is a plastid, is a type of plastid. Here you call it perimitochondrial space. Now, the wise ones know that the entire saga is going to be about periplastidial space, perimitochondrial space and matrix. Right now, at this moment, what I'm going to do is, I'm going to give it a short form, which is not official. It is just to make life easier in the rest of the session. Or you can call it IMS also. Okay? I'm going to be using the short form, right? Now, do you see these foldings? They are so significant here. Okay, and what do you call them? Answers in the chat box, everybody. You call them cristae. And the purpose of the folding, whoever made the folding, Brahma made the folding, was to increase the surface area of respiration. That's what we've been saying since childhood. To increase the surface area of respiration. Today we are going to understand how and why. So, to give you the hint, there are particles studded on cristae. Answers in the chat box. What am I making? What am I making? What did I just do? Out of nowhere. What did I just do? I made F1, F0 particles. Heard about them? From a very nice Pankhuri ma'am. Heard about them? F1, F0 particles. Remember, we played tennis in the last class. Yeah? And we can't forget, let's get to the inner side. Membrane part is done, very nice. Now, membranes are enclosing the mighty matrix, aren't they? Yes, no, maybe. This is the matrix. Now, when I say enzymes, you guys have answered it. Matrix has the enzymes for Krebs cycle, which is the step after glycolysis. Remember, your aim today is to make a lot of energy. You've made some of it. Very good. Congratulations. And your aim is to change this or break this glucose into carbon dioxide and water. You've done nothing out of it. You're nowhere. So we have to really look forward to what is happening now. Okay? And what is so special is that it also has this organelle also has its own ribosomes. Now, who is going to be my darling and tell me in the chat box what kind of ribosome it is? You have 80S and you have 70S. You have cytoplasmic ribosome and you have the prokaryotic ribosome. You have the prokaryotic ribosome 70S. That simply means I have my own protein factory. Wow. And also, I am blessed by gods. Okay. What did I just do? Guys, your diagram has to be a good diagram. Sorry for doing this. I would say label on the same side, short of space. Yeah. A neat diagram is very important. Either don't write any notes, or when you write them, they should be so goddamn lovely and a treat to the eyes that you go back to them, revisit them again and again. You can't stop yourself. You're like, hey, I just want to look at my notes. They're so lovely to look at. You know what is the scientific reason? You create a photogenic memory. Trust me and tell me how many of you have experienced this. You sit in the exam center, you see a certain concept, and you know, suddenly the picture of your notes, suddenly that image of your notes comes in front of you. That really helps with the accuracy level. There's a reason why I'm working so hard in making the notes for you. Otherwise, it's easy to go through this chapter in 1.5 hours, 2 hours also. So make sure you have beautiful notes. This is circular DNA. Circular double-stranded DNA. Yes. Now, both these factors, having my own ribosomes and having my own DNA, makes me, okay, both these things are making me a semi-autonomous organelle. What does that mean? Well, if my body suddenly requires more of energy, I'm going for a run, I'm working out, I'm lifting heavy buckets of water, or whatever, I'm jumping. Alright, so mitochondria can increase in number, but for its survival, for its sustenance, it has to be dependent on the cell. So we use the term semi-autonomous, not complete autonomy. Is that very clear, boys and girls? Everything is very clear. Now, boys and girls, F1, F0 particles are extremely important. They are definitely the same particles that you have studied with me in photosynthesis, but they are known by many names. So before you get confused reading theory here and there, which I am totally against at, you should just refer to the class notes if you have associated yourself with one teacher, and you should study NCERT. But different authors use different names for this Pichara particle, which we are going to do. So to keep you safe and healthy, let's write whatever possible I can hear about F1, F0 particles. Well, I call them oxysomes. Oxysomes. Why do I call them oxysomes? Because oxidation reduction reactions lead to activation of this particle. Okay? It is called as F1, F0 particle because of the structure. Last class, what is this? F0, the stock. F1, remember, I was the greedy lumen, you were the nice stroma, stroma. Yeah, I accumulated all protons and you guys gave me all protons. The stock or the tail or the foot, this is the head. That is why I call them F1, F0, although it looks otherwise, right? The head looks like, the head, yeah, looks like a 0. But then that could be a trick to remember. They're also called as elementary particles. So don't be surprised if you see that. They're also called as Fernandez-Moran particles. Especially if you study them in the chapter of cell, you would often see the mention of Fernandez-Moran. Not very popular. Why? Because these gentlemen discovered these particles. And you also know them as, I have to make it 5, it is also known as the coupling factor. Why is it called as the coupling factor, boys and girls? Because only and only owing to these particles, I can couple up ADP and inorganic phosphate to make the mighty ATP, which is the aim of my life. Who am I? I am the cell today. I am the cell today. Is this very, very clear to everybody? Now we move on to Krebs cycle. Oh, there's a question. Bad habit. Chalo. Answer in the chat box. Quickly. In my classes on the platform, when I solve questions, I am very unforgiving. I give 20 seconds to 30 seconds only. Quickly means quickly. That's why I say pure attention is needed in today's class. The questions are going to be challenging. Yeah? People are saying 1 also. What? I hear your voice in the exam hall. Yeah, I'm getting some messages from certain notorious people of my class. Ma'am, we hear your voice after the class. That can be actually a good sign. If the voice is about concepts. Okay. 78, blah, blah, blah. Chat GPT is doing very well. Oh, Sushma, yes, you're right. Yeah, but more than a botany class, darling, chemistry class should be able to tell you that. Okay. Saucy is Saucy. Okay. Anant is there in the class. Oh, thank you for your gracious presence. Okay, let's solve this question. Did I block your way again? Cool people. Let's read this question. So, the rule of the hour is, if you are appearing in 2024, every question asked in last 10 years. Mane? Last 10 years meaning? Minus 10 from the year you are going to appear is a probable, valid question. 80 to 90% probability of that question being asked even with the same language is going to happen. Okay? And like a broken record, a CD that has been stuck, I say this in every class of mine. So please, that is why I bring these questions into the class. Which of the following statements regarding mitochondria is incorrect? Very beautiful. Mitochondrial matrix contains single circular DNA molecule and ribosomes. Oh, this is so correct. That is a special blessing that this organelle has. Outer membrane is permeable to monomers of carbohydrates, fats and proteins. Outer membrane is rather permeable. Inner membrane is very selective. Inner membrane is called selectively permeable membrane. I know you guys have been taught, or you say semi-permeable, but a better term is selectively permeable. Happy? Enzymes of ETS are embedded in the outer membrane. No. Let's go back. Let's go back because I see some wrong answers. Yeah. So, in photosynthesis itself, we studied electron transport system, chemiosmotic hypothesis, Mitchell's hypothesis. Yes, no? Remember from last birth? In F1, F0 particle, electron transport system will take place. Same thing, jumping of electron from one carrier to another, same thing, chemiosmotic hypothesis. That is the identity of F1, F0 particle. Where are they located, Baba? Inner mitochondrial membrane. So that is also a true statement. They are proteins, they are enzymes only, na? So this is wrong. Inner membrane is convoluted. Convoluted means folded. Just a fancy term. With infoldings. Just like a bacterial cell has mesosomes. Yeah? Some of you answered 4 also. Why do you do that? Yeah? You break my heart when you answer wrong at such basic questions. Come on. So, third statement is incorrect. I hope it's clear to everybody. Let's go further. Now we are going to Krebs cycle. Ooh. After Krebs cycle, we will do, I'll give you a break. Promise. Guys, you know what? It's not, absolutely not easy and fun to stand here for 8 hours and take a lecture in one shot. Yeah, it takes a lot, and I speak for every teacher of this team who's doing that. So before you ask for a break, we will take a break, dinner break after Krebs cycle, and we'll do ETS after the break. So this cycle, why is it called Krebs cycle? Let's start the introduction. As was the promise since we met the very first time, that we will always do the basics and then go to the advanced concepts. Starting from basics, this was discovered by Sir, I don't know, I like calling it that way, Hans Krebs. And it is very exciting for me to mention, I think it is given in NCERT, he got a Nobel Prize in, tell me if I am wrong, it was very recent, post-independence, 1954. That amuses me to the core here. You know, we have been studying the discoveries in living world in biological sciences from 18th century, isn't it? So in terms of the time period of discoveries, you know, plant physiology is still getting discovered. When your children will study photosynthesis and respiration, yeah, some of you will be like, never ever I'm putting my kid to this. They could be studying something entirely different about photosynthesis and respiration. It is quite a possibility that whatever glycolysis and the counting that you did with me could absolutely be refuted and ruled out. Yeah. So 1954, if I'm not wrong, is quite recent. Now the site of Krebs cycle, site is a usual question. Site is mitochondrial matrix. Mitochondrial matrix. Boys and girls, please make sure that you don't mark inner mitochondrial membrane. I request you from my heart. This is a negative marking that you will definitely, I will be devastated if you do this. ETS is not a part of Krebs cycle. It's a third independent step. Only and only Krebs cycle will happen. Promise me right now in the chat box. I want everybody to write promise in the chat box. Okay. Now, it is also known as, the nicknames if you will, also known as citric acid cycle. Citric acid cycle. Why, ma'am? There is a why to everything. You just got to ask. It is called because this is the first stable compound. AR question. First stable compound. You know, in a biochemical process, what you see is not the only truth. You are studying the tip of the iceberg. A biochemical process is a multi-step process. So there are many unstable intermediate compounds which are formed, they don't remain in the system. But when we study biochemical process at your level, we focus on the stable compound which is going to take the lead. For example, in glycolysis, PGAL took the lead in the payoff phase. We don't care about the ketone part. We know it exists, but it did not take the lead. So here the first stable compound is citric acid. Now chemically, we know citric acid has 3 carboxylic groups, 3 COOH groups. You guys know it better. So I gave one more nickname. Meera kya ja raha hai? It is also known as TCA cycle. It is also known as TCA cycle. Why? Easy, no? 3 carboxylic groups. Yeah, the first substrate, the first compound is always given a lot of importance. If you remember Kelvin cycle, what was the other name of Kelvin cycle? Right now, you tell me. Or what was the other name that I taught you about photorespiration? Yeah, you see the naming of the cycle is always based on the first stable product. C2 cycle, C3 cycle, C4 cycle, because in C4 cycle I am getting oxaloacetic acid. Phosphoglyceric acid, C3. Makes sense? So you call it TCA cycle. Now, this cycle, right now, if you haven't heard anything till now, kindly hear what I am going to say in the next 1 minute. I am introducing a term called as oxidative decarboxylation. Yeah? Oxidation means removal of hydrogen. Addition of oxygen is also applicable, but here what I mean is removal of hydrogen. And decarboxylation means there is removal of carbon dioxide. Yes ma'am, we agree. Very basic ma'am, no problem. Is that clear? This cycle, if I have to, now, why did I introduce this term? It's not given in the textbook, ma'am, what are you doing? Because the examiner is going to use this term like it is your second language. So before you go all bananas about it, make it, familiarize yourself. Is that very clear? This class is all about making tough concepts very, very palatable. If you don't want that, be at a better place. Alright? So, when I say it is a cycle, that means everything is happening again and again. What is happening again and again? It is a cyclic process of oxidative decarboxylation. Boys and girls, I promised around 5:30 p.m. We both promised that we are seeking formation of energy, we are seeking formation of carbon dioxide, we want water. We saw the equation. Yes. So now what does it tell you? When I oxidize a substrate, I am telling it to give me hydrogen. That hydrogen will be used to make reduced coenzymes, the reducing power. I also mentioned at 5:30 p.m. approximately that energy is not absolutely formed in the beginning, just in the form of ATP, purest form of currency. The hero of the story, yeah, I told you it is NADH2. What is NADH2, yeah? It is a reduced coenzyme. Everybody give me the full form of NADH2, come on, in the chat box. Fast, very, very fast. Fast means fast. Otherwise, no talking in the endgame batch. Very serious classes will happen then. Don't tell me later, ma'am, what a serious class. Okay. So, this is going to lead to the formation of energy and carbon dioxide. So, slowly and gradually, I am moving towards my aim. I don't do it in one go, and that is very, very useful for the cell, that I don't do it in one go. I'm patient. I do it at every step, little by little. And gradually, you will also understand in a multi-step controlled manner how it is useful for the cell. What is present in microcosm is present in macrocosm. So, I am also going to teach you that way. Okay, and CO2 are formed. Happy? Feeling healthy about the concept? Very important here. Now, the problem, there is a problem. The problem is the cytoplasmic pyruvic acid. The cytoplasmic pyruvic acid, or let me rephrase it. The glycolytic pyruvic acid cannot enter mitochondrial membrane. Okay, I need a shuttle system. I need carrier proteins. They are called MCPs, mitochondrial carrier proteins. First point first. Now that's not in your syllabus. You'll do that at the postgraduate level, MSc botany or something. But what is important is that pyruvic acid cannot enter Krebs cycle. The cell just doesn't like pyruvic acid as it is. So there is something called as link reaction, boys and girls. There is something called as link reaction. Very serious. Which we are going to do now. What happens in link reaction? Everybody is in tune? Yes? To start with very basics, I am conversion of pyruvic acid into acetyl coenzyme A. This is what is link reaction. Let's talk basic. This is what you are seeking. Always know what you are seeking in a reaction. Guys, is everything fine? Why is it called a link reaction? If I have given a name, there is some reason for that. Because this is linking. Acetyl coenzyme is the entrant substrate. Entrant substrate. Krebs cycle will not start till you give mitochondrial matrix acetyl coenzyme A. He is very strict. Being strict is good. You don't do random things. At least they are not happening at the cellular level, at the nature's level. That reminds me. Now you guys were requesting so much. I was getting messages. I saw all the comments. Ma'am, please do ecology. We are scared of ecology. Ha ha ha. So since we are finishing plant physiology today, and congratulations for that, come what may, today we will be done and dusted with plant physiology. Next week, same time, same place, same person, same channel, we are going to start with ecology. I think the team has scheduled it on the channel. Yes? Confirm it once. Right now, I want you to like that session so that it remains in your liked videos. Very, very important organism and population. The very first chapter of ecology will be done on 14th of February. Yeah, your request is taken like all other requests. You guys are so lucky. So link reaction, because it is the link between glycolysis and Krebs cycle. Each and every point is very important. How many points do you have? Count it. 1, 2, 3, 4, 5, 6. No, I'm not going with 6. So what is link reaction? Let's write link reaction. It is very, very important. Give me some smiles because we are going to start with ecology. Yaar. Come on. Don't keep a serious face on. Not worth it. I said smiles, not hearts. Whatever is deleted, these classes are happening according to the new syllabus here. Are we meeting for the first time? क्यों ऐसा करते हो? Shabana, I answered here. Ask me a good question. Whatever is deleted, I won't do it. Or I might just, you won't realize it, but yeah. Ma'am, can I watch ecology from Avengers batch as you have already taken there? Well, if you're going to appear on 5th of May and you have studied the detailed lectures with me in Avengers batch, it is the time that you watch one shot. So I would recommend that you connect with me in the live class. Anything else? Oh, anything else? Nicotinamide, adenine dinucleotide. Very good. Is it Cran's anatomy? Where is Cran's anatomy coming here? Where are you guys talking from? Which planet? Okay. 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 No, I am not blushing at all. Yeah, it's what is link reaction? I have pyruvic acid. Okay. And how do I convert it into acetyl coenzyme A? That is the question. Ladies and gentlemen, there's a reason that I focus so much on the term oxidative decarboxylation. Kindly be very, very sure that this is the first. If I am the examiner, I would definitely love to ask this question. Which is the first oxidative decarboxylation that happens in Krebs cycle? Now again, if it is not mentioned specifically in your question, link reaction can be considered as a part of Krebs cycle sometimes. You have to approach the question carefully. So the first oxidative decarboxylation will happen, which simply means that this pyruvic acid, which is a 3-carbon compound, okay, is changing into a 2-carbon compound. So decarboxylation is happening and also oxidation is happening. So I am going to get a lot of energy. The energy is trapped by NAD plus and I get NADH. Is that very clear? NAD plus is a oxidized coenzyme waiting in mitochondrial matrix. Somebody please give me energy. I want to be reduced as well. Okay. The enzyme that is applicable here is pyruvate. Okay, one more trick of the hour. Okay, if it doesn't make sense to you that where energy is formed, take it from me today. I'm going to make your life easy. Whenever you see somebody mentioning the word dehydrogenase, now you guys know that dehydrogenase means I am removing hydrogen. Yes, ma'am. This much we can do, ma'am. Little bit we'll also do, ma'am. Yeah, it's okay. After all, admit card has our name on it, yeah. This means I am removing, this enzyme is going to remove hydrogen from this substrate. Is that clear? So this guy is getting oxidized. And what else is happening? This particular enzyme, in this particular case, not all dehydrogenases, but pyruvic dehydrogenase in link reaction requires a lot of cofactors. You've done biomolecules, right? You know what cofactors are. Are we very clear? So instead of saying pyruvate dehydrogenase, kindly be precise. You deserve to be precise, being a NEET aspirant. You call it complex. Now when I say there is a complex, I mean real business. It is called a complex because it involves the activity of the enzyme itself. Who all are a part of this complex? Number one, the absolute pyruvate dehydrogenase complex. The enzyme that is helping in removal of carbon dioxide here. How can you ignore that? I cannot work without a decarboxylase. Every step is enzyme controlled. I promise that at 5:05 p.m. So decarboxylase, I would require magnesium cation. I would definitely require magnesium. I would require TPP, which is thymine pyrophosphate. Okay, this is simply TPP if you see the mention. And I would require lipoic acid. Are we very clear? And some authors also include NAD plus into the complex. Not a problem, we can. Very clear means very clear. Now, hold your guns, eyes on the screen. Let's check the reality of this. Everybody. This is seen for one molecule of pyruvic acid. How many molecules of pyruvic acid did you get at the end of glycolysis? Answers in the chat box. You got 2 molecules. So link reaction will happen for both the molecules. Okay? There is no cheating. So what we are going to do, you have to be very particular about counting the number of carbons in your substrate. You have to be very particular about number of molecules. I tell you, the questions go wrong. Every complication in the life happens when you stop doing that. People ask me how to make this chapter easy. Why am I going wrong in respiration? So many of you come after mock tests, message me, ma'am, respiration was there in the syllabus. I've read the chapter 10 times, 15 times. Ma'am, I watched your lectures also. Still, I'm losing marks in respiration. Ma'am, what is happening? Every chapter requires a different kind of effort, different kind of attention. So, into 2. Into 2, everybody. Write the notes. You will get into 2. And you will get into 2. Yes? Now, as was the promise, let's write every step of respiration, whatever we indulge in discussing. However minuscule it is, we are going to talk about the net gain. So, net gain, what is happening here? Yeah? I am getting 2 molecules of acetyl-CoA. I am not saying energetics. I am not only talking about the energy part here. I am talking about whatever is formed after the reaction. I am getting 2 molecules of CO2. Remember, your equation from the earliest part of the evening had 6 molecules of CO2. Always remember where you are headed. What do you seek from a particular biochemical reaction? Everybody is on the line. 2 CO2 you have formed. Okay, and you are going to form anything else? Oh, how can I forget? You are going to form 2 NADH2 in the mitochondrial matrix. Already 2 NADH2 are lying in the cytoplasm. They are waiting. They are waiting. Very clear? Yes, and acetyl coenzyme A is now going to enter. Oops, where is my Krebs cycle? Okay, is going to enter the cycle itself. Let's draw the cycle together. We are going to pace it up. We are not going to go very fast. Okay, pacing of the cycle is important. Slowly and gradually we'll absorb it, we'll understand. Everybody is ready for Krebs cycle? After Krebs cycle, I'm giving a break like I promised. Now, when Krebs cycle enters depends on how quickly you understand. Good evening, Ratnesh Kumar. You are too early for the next class. Okay, good evening. I have to be less strict. Cherry guy, just ask the question. Okay, great. Now, tell me the starting substrate here. Participate. Acetyl coenzyme A is how I start. In this cycle, this guy is going to combine with or condense with oxaloacetic acid. Heard about him? C4 cycle. How many carbons are present? Let's count the number of carbons. Never ever fail to count the number of carbons. Okay. So, oxaloacetic acid has 4 carbons like you guys are saying. On the reaction side, I have 6 carbons. So, my first compound, not a surprise since we have discussed that already, is going to be citric acid. How many carbons are you expecting in citric acid? You know, remotely some authors have called it C6 cycle also. I don't know why to give so many names. I would never know. Okay. Now, the enzyme that is involved here, not a surprise for us. Easy. Citrate synthase. Guys, in textbooks and study materials which go random, which you should not refer, there would be a lot of steps in Krebs cycle. Okay, keeping in mind the relevance, this is also a 10-step cycle at your level, not the reality. Theoretically, at your level, you see 10 steps in Krebs cycle. I am going to speak about the relevant steps which can fetch you any question, and I am going to amalgamate. I am going to form a concoction so that NCERT is also done and questions are also done. Okay. Now, this citric acid is going to go further and give me isocitrate, which is unstable. If you think, please don't look at the cycle given in NCERT. I request you to do that. Please don't. No good is going to come out of it. Isocitrate also has 6 carbon atoms. It is unstable, and quickly, with no wastage of time, it is going to change into oxalosuccinate. Why did I tell this step? It is not given anywhere. Why? There's a reason here. I will not do anything without a reason here. Are you writing? It's okay to be slow right now. Then rush it and regret later. So, you can distance them. I don't have this space. I want to do the cycle in one page. But if you take the landscape mode, distance it nicely. Draw a beautiful one. Go all good. Use the vanity. Is it clear? Now, why did I include this like I was saying? The enzyme here, eyes on the screen, the enzyme here is dehydrogenase. What did ma'am tell you a while ago? Boys and girls, whenever you see or hear somebody mentioning the enzyme dehydrogenase, that means the substrate is losing hydrogen or getting oxidized, and that is coupled with formation of energy. I'm not talking about the form of energy, but some hydrogen acceptor will be there to catch the hydrogen. Okay, and this further speaks about the oxidative part of oxidative decarboxylation. So when this happens, I get color de do mujhko koi to. Ma'am, don't use red. So I get NADH2. I get what? In orange, I get NADH2. Wow. This is just the oxidation that has happened. When oxalosuccinate changes into the next substrate, which is alpha ketoglutarate, I see that this is a, let me write the number of carbon atoms, this is also 6, this is a 5 carbon compound. Alpha ketoglutarate is very, very popular. Why? Who will tell me? And clearly decarboxylation has also happened. This is the first oxidative decarboxylation where I started from citric acid. Okay, and while I reach alpha ketoglutarate, even if you want to miss these steps, citric acid to alpha ketoglutarate, oxidative decarboxylation has happened, and I ascertain that as a result of oxidative decarboxylation, energy will be formed and carbon dioxide will be formed. Energy is formed, carbon dioxide is formed. Thank you very much. My starting compound is 4 carbon. In a cycle, I always go back to where I started from. I always go back to where I started from. So this means there's something else also that is left. Now, like I asked, why it is called as, I'm going to use red. The most important step. Let me see here how not visible it is. You guys are right to some extent. Okay? Because alpha ketoglutarate is the most important intermediate compound to form proteins. This alpha ketoglutarate, if it is not taken away, snatched by the cell to form proteins, then it proceeds further to form any answers? Succinyl coenzyme A. Boys and girls, eyes on the screen. Eyes on the screen. Everybody. Read this out. Alpha ketoglutaric acid changes into succinyl coenzyme A, which is a 4-carbon compound. Once again, eyes on the screen. Alpha ketoglutaric acid, which is a 5-carbon compound, changes into succinyl coenzyme A, which is a 4-carbon compound. Does this seem similar to this one? Once again, eyes on the screen, everybody. Pyruvic acid, which is a 3-carbon compound, changes into a 2-carbon acetyl coenzyme A. Do you see the similarity? So what is going to happen is that even if you want to forget other enzymes, this is important. Here you will see dehydrogenase complex. Dehydrogenase complex, and not just dehydrogenase enzyme, because you are adding coenzyme A. You are adding, it is absolutely the similar reaction. So dehydrogenase complex. Which dehydrogenase complex? Alpha ketoglutarate dehydrogenase complex. Simple. Of all the people in the world who are scared of big names in biology, at least botany is so simple, isn't it? So just if you look at that reaction, I am going to form, we are going to give the same color to the energy. Okay, I am going to form, this guy is getting oxidized, is going to form NADH2. Second case of oxidative decarboxylation. Your NCERT says it, 2 consecutive after look at the theory part. If your NCERT is open, it says after formation of isocitrate. I think she mentions isocitrate. There are 2 consecutive oxidative after formation of isocitrate. This was a question in NEET 2022. Everybody confirm it who have their NCERT open. Yeah, ma'am, even if it is not open, we will say yes. Don't think I'll know. After isocitrate, there are 2 consecutive or successive oxidative decarboxylations. 1 and 2. 1 and 2. What is the color of carbon dioxide here? We have pink, because you guys don't let me use any other. CO2. This succinyl coenzyme A is going to see the addition of the acidic group, alright, and it is going to change. I don't like this. It is going to change. Spacing is a big problem. Draw a beautiful cycle. Would you? It will see succinate or succinic acid, everybody. I will let go of the coenzyme A. Bye bye, thank you. And I am also going to add phosphoric acid here. Well, you can leave that, it will further confuse you, never will be asked. The energy with the release of coenzyme A is very, very significant. We are going to form the mighty, the star of the show, not the hero, I said star of the show. We are going to form ATP. Boys and girls, if this these two have been called repeatedly by me as oxidative decarboxylation, like a parrot. What do you call? I spoke about the different ways in which energy is formed. What do you call this phenomenon? That I am getting ATP because of this substrate, but there is no decarboxylation because succinic acid is also a 4-carbon compound. Don't assume. Now you can't do any decarboxylations. Don't force a decarboxylation. Be very careful of the carbon atoms. Your starting compound substrate is a 4-carbon compound here. You've already reached a 4-carbon compound. Carboxylations are done. Or in other words, 2 carboxylations are happening in TCA cycle. Not more than that. This is also a previous year question. I will show you. I have all the kinds of problem patterns, questions that can possibly be asked in your paper. Okay. So, only 2 carboxylations will happen. They are done. Now, in your NCERT or in other texts, you would see GTP as the other compound. You would also see GTP. GTP is considered as ATP equivalent. It is considered as ATP equivalent. Then ma'am, why? Why are you complicating our lives? GTP is guanosine triphosphate. Not adenosine, different from adenosine triphosphate, but in terms of energy equivalent, it is considered the same. Is that very clear? Now the question to why is, well, GTP is formed in animal cells. Where do I write it? Jindagi. Let me find space. You write it nicely, okay? You write it nicely. So, क्या है? Oof. And the AC works on me every time. So, GTP is formed in animal cells. This much is enough for you. And ATP is formed in plant cells. Is this much information okay? Well, it has to be. Done? Digested? After succinic acid, how do I reach oxaloacetic acid? Well, I am going to form fumaric acid. Fumaric acid. Is that clear? And this step is definitely going to fetch you an MCQ, because even when I gave my exam long back, many years back, this question was the most asked question out of the enzyme part of Krebs cycle. When succinic acid changes into fumaric acid, boys and girls, the enzyme that is involved here is succinate dehydrogenase. What was the promise we made? Ma'am, whenever we will see a dehydrogenase being mentioned, we would know that there is energy being formed. Is that very clear? So, I am certain energy is formed. But the form of energy is not NADH2 or ATP. It is FADH2, boys and girls. Now, is this color visible? Where am I? Before you scream it out, it's not visible. Okay. Don't start. I want to give a color, different color to every energy molecule just to create a photogenic advantage for you. But clearly, I don't have the color. ठीक है. So, we will form FADH2. Now, there are some people who are over optimistic in life and they might assume that, ma'am, just the way GTP was ATP equivalent. Am I disturbing the mic? I am. Just the way GTP was ATP equivalent, FADH2 is equivalent of NADH2, ma'am. You are absolutely wrong. And you could create a disaster if you assume that. It is not equivalent to NADH2. It's a flavoprotein. Flavomononucleotide. It is write it nicely. Ma'am doesn't have space. What will you write? But I'm trying to give you the cycle on one page. FMN is flavoprotein. Flavoproteins are, you don't have to get into the details of it. Iron containing proteins. And their metabolism is different from other kind of proteins. So, flavomononucleotide. Write it very clearly here. This is formed. Okay? Now, succinate dehydrogenase, why is it so important every year? Even when ma'am sat for the exam 50 years back. What is so special? Who will answer in the chat box? Come on. I've been talking since so long. What is special about succinate dehydrogenase? Everybody. While I tie my hair. Why am I so focused? Categorically. Not on citrate synthase or even alpha ketoglutarate complex, but succinate dehydrogenase. You study this in biomolecules actually, not in this chapter. Yeah? This is the only enzyme of Krebs cycle which is present in the inner mitochondrial membrane. Or in other words, it's a membrane bound enzyme. It's a, write it nicely in a different bubble. Only membrane bound enzyme. All other enzymes are present in mitochondrial matrix. Is this ultra clear in your heart? Okay, this is done. Now fumaric acid is going to change into, if you would count, you will easily get 10 steps. It will change into malic acid, people. Malic acid. Interestingly, there is no dehydrogenation which will happen here. Okay. So, fumaric acid will change into malic acid just by the addition of some water, by hydration. And the enzyme will be fumarase. You can forget about it. When this malic acid changes into oxaloacetic acid, big things happen in life. Because I have the enzyme. This is just to make your life easy. I have the enzyme malate dehydrogenase. Okay, dehydrogenase. So what do you think is happening? Scream it up. What do you think is happening? Energy is being formed. There are three kinds of energy that I've seen today. I have the purest ATP, I have the reduced coenzyme NADH2, and somebody new called as FADH2. Do you think there is a fourth form? Thankfully not. We don't want any new forms. So here also NADH2 is formed here. You will form one more NADH2. Kindly make it. Happy? Now let's talk numbers. This is the cycle. And if you are thinking that in one go, just listening to me once or reading this once, you should get the entire cycle, and or the other side of it, you are absolutely, you feel like giving it up on the cycle, and you are confused and you are thinking, what am I doing here sitting in this class? All of those are very good signs. You are not supposed to get Krebs cycle without reading it at least every day for 7 days and reading it multiple times. So you guys like sticking notes here and there. Stick the cycles. The only trick, I know that YouTube is full of mnemonics for cycles, songs and whatnot, and you know, if you know me for a while, that I'm totally against it. I feel that you got to make it a habit. You got to do it more and more. Rather than putting your precious energy and mental space into learning mnemonics. Don't do that to yourself. You're going to thank me one day. So, leave the idea, and that I would say for physics also, chemistry also, or anything in life, kindly leave the idea that you're supposed to get things in the first go. That is the cause of unhappiness and stress that you face in your NEET preparation. Yeah, whenever you ask me, ma'am, I feel stressed, I feel anxiety, because you are not conditioning your brain. I have to get this chapter of chemistry in one go. I have to understand this chapter of physics in one go. That's a myth. You are escaping from hard work. There's nothing like one go. Nothing happens in life in one go. If it's happening, then there's something wrong. Okay, so the idea is that after the lecture is over, somebody can put the duration timestamp of Krebs cycle in the comment section, or you can note it down right now and rewatch it. Rewatch it, revise it. That's why I've put it on one page. But hold your guns. Like I've been saying, hold your guns. We are not done yet. We are not done. This is not the truth. Eyes on the screen, everybody. Our eyes on the screen? I mean on the cycle, not on me. My voice is enough. Everybody, give me a shout out. I want some fire. I want some josh, some energy. Shraddha, you got to keep certain things to yourself here. Ma'am, I have pasted my wall. Don't paste your wall. Leave the wall, poor thing. You know, when you overdo a certain thing, we'll keep a special class on the platform, huh? To increase your retention. I'll tell you how to do it. Krebs cycle is not done yet. It is not done. Sakti, same to you. Laharika, tell the Unacademy team यार, colors ही नहीं देते हैं मेरे को. Ma'am, did you write NEET? Thank you, but I'm not so young. I wrote AIPMT and I wrote a lot of state PMTs. I was eligible for 3 or 4 states. I was eligible in Karnataka CET, I was eligible for Punjab PMT, I was eligible for Haryana because that time you could carry multiple domiciles. Yeah, and owing to parents who moved in every state of the country, that's what I had quite a nice time. I came here for first time heart, but in the mid session. Wow. Welcome to the class. You guys don't have any doubt? Saucy, why my ears left the class? Why? It's not always nice with me, you know, I like troubling my students also. You're not the only one. So, I'm going to use pink. Now don't say, ma'am, don't use pink also, red also, white also. I need colors here. Laharika, it's somehow not there. I'll figure it out though. Cool hai. Okay, bye. Thank you very much. Now let's talk real deal because I'm sure you guys are waiting for the break. Somehow I forget about a break whenever I'm in the class. Yaar, eyes on the screen. How many molecules? Answers in the chat box. How many molecules of acetyl coenzyme A entered the mitochondrial matrix? A JEE student should be able to answer now. I'm teaching from my colon. Bolo, how many molecules? Pakka? Sure? Sure means sure. Yeah? So, let's go back to the link reaction. Yeah. In this chapter, I'm repeating like a parrot. It's the game of number of carbon atoms, number of molecules. Number of carbon atoms, number of molecules in terms of accuracy. If you want to eliminate the chances of negative marking, kindly revise every time you read a cycle. Don't be a cuckoo. Open up the NCERT, see the cycle, done. That's what you do. That's what I did as a student. There was nobody to tell me to do otherwise. I'm telling you, revise what is happening with the carbon atoms, what is happening with the molecules. 2-acetyl coenzyme A means whatever you just saw is going to be into 2. Can you digest that much? Into 2. This means 2 molecules of acetyl coenzyme A not only formed all these substrates into 2, but let's focus on what we are interested in. Into 2. Into 2. Into 2. Carbon dioxide into 2. NADH2 into 2. Okay. Then what else is happening, people? Into 2. Let's count NADH again. Into 2, into 2, into 2. How many times did I say into 2? How many times did I say into 2? I'm counting NADH2. Into 2, into 2, into 2. How many times? 3 times. This means in actuality, not for one Krebs cycle. For one Krebs cycle, very easy to see that 3 NADH2 are formed, 1 FADH2 is formed, 2 CO2 are formed. Arey yaar, my hair always do this here. If only I could cut them. Never ever that is going to happen. Huh? So what you're going to do is either you learn it this way, that you count for one Krebs cycle and then do it for 2. That in one Krebs cycle, 1, 2, 3, carbon dioxide, 2 carbon dioxide were formed, but here I have to do into 2. I've already done it. So 4 carbon dioxide are formed in actuality, and it's not like acetyl coenzyme A, one molecule will undergo Krebs cycle and the second molecule will be like, yeah, I'm waiting. Arey, when will my chandu? Yeah, they happen together. They enter together, they undergo oxidative decarboxylation or Krebs cycle together. Is that clear? So, in actuality, 4 carbon dioxide are formed. FADH2, let's count FADH2 into 2. Let's do into 2. How many times did I say into 2? Once. So, 2 FADH2 are formed. ATP or GTP into 2. How many times did I say into 2? Once. So, 2 ATP molecules are formed. Yeah, Saucy is like, what have I done to deserve this? Why is ma'am doing this? Is this clear? Very beautiful Krebs cycle. Yummy. Only thing is you need to revise it. I'm not going to buy the fact that you understood it all. Okay? Arey, what are my hair doing here? They're playing with the board while I'm talking to you. Where is succinyl coenzyme A? What is happening? Some supernatural things are happening here. ठीक है? Be very precise about these facts. Your notes should have everything. Flavomononucleotide, succinate dehydrogenase, this is SLP, substrate level phosphorylation. Now we are going to talk business. B cheese, the energetics. अबे ये क्या है? अरे okay, wait guys, energetics we need to write. Ready? Let's count like there's no tomorrow. Oh, energetics. Somebody asked me today, one of my favorite people, I mean a student, ma'am, what do you mean by energetics? I have realized whatever is not given in NCERT or study materials, we just don't want to use common sense or make sense out of anything. Yeah, kindly take out common sense from your refrigerators, freezers and apply it. This any competitive exam of this country, whether it is UPSC, CLAT, MAT, NAT, ZAT, excuse me for saying that, but JEE, NEET, if you think you can function without common sense, you're in for a surprise. So, energetics, ladies and gentlemen, we will start with link reaction. Link reaction. I am not talking about the net gain. Just tell me what energy did you form in link reaction. Answers in the chat box. 2 NADH2. Yes, no? Okay. Then after link reaction, I have the mighty Krebs cycle. I have the Krebs cycle. In Krebs cycle, I formed a maximum amount of energy here at many places. Let's talk about the hero of this story. Who is the hero of this story for today evening? NADH2. How many NADH2? Now, I am risking heartbreak. Guys, how many NADH2 are formed in Krebs cycle? In one Krebs cycle. Oh, somebody. Are you sure? Not 3? Not 3? I said one Krebs cycle. Okay, if you guys say so, 6 NADH2. Thank you. Then, something else is also happening. What else is being formed here? How many FADH2 are formed? 1. How many FADH2 are formed in one Krebs cycle? 6, huh? Sushma, people are saying 3 FADH2 are formed. Kill me. 2 FADH2 are formed. Okay, thank you very much. How many? How many ATP are formed by substrate, by SLP? 1, 2, 3, 4, whatever. Number ही तो लिखना है. 2 ATP. Thank you. I hope you are writing it with sense. This is the energetics. Isn't it? So, the net gain, if I have to calculate, you know what I am going to do? I am going to tweak it. I am going to tweak it so that you can solve any kind of question. Yes, commonly the question is from the energetics. I agree, point blank. But what if the paper is tricky? How many carbon dioxide, although not counted in energetics here, how many carbon dioxide are formed in link reaction? Humko kya malum? I'm done with ATP. Move on. How many carbon dioxide are formed in link reaction? Thank you. Are you sure? 2 carbon dioxide. As simple as 2 molecules of pyruvic acid, 2 carbon dioxide. Okay? These NADH2 which are formed, okay, tell me how many CO2 are formed in Krebs cycle along with NADH2 taking care of oxidative decarboxylation. They both happen together. 6 CO2, everybody? Is it 6 CO2? How many times did I say into 2 for CO2? Two times, right? So 4 CO2. To remind you, oxidative decarboxylation is happening. Happy? This is SLP. So now what is the net gain of everything? Let's include energy also, let's include everything. After glycolysis, thank you God, cell is like thank you God, I am getting 6 plus 2, 8 NADH2. This is all. Why did I combine link reaction? You will hear different versions of energetics from different people. As far as respiration is concerned, study it from one teacher. because people have various kind of countings. You will reach at the same destination. The idea is to make 38 or 36 ATP molecules, but 8 NADH2 I have combined because everything is lying in mitochondrial matrix, whether it is link reaction or it is Krebs cycle. Okay. Then 2 FADH2 and 2 ATP, and very excited, 4 and 2, 6 CO2 are formed. Why am I so happy about it? Well, I am happy about all the concepts, because in the early part of the evening when this session started at around 5:15 p.m. I had spoken something like this. I think earlier than that. C6H12O6 plus 6 O2. This is my aim. 6 CO2. Everything is fine, right? Plus energy plus 6 water. You got it. Not only you made humongous amount of energy, we are nearing our destination. It should make you happy. But then for that you have to fall in love with botany. I don't know if I have done that to you. Some people are infected with the love for botany. Yeah. So I am making energy, considerable amount of energy. This is considerable amount of energy. And I have formed 6 molecules of CO2 by the end of Krebs cycle, because after this I don't have the chance. Good. Are you following this? Ready to solve a question? Everybody? Before that, let's decode NCERT. Do you want me to skip it? You guys will be able to do NCERT. After learning it from the teacher, NCERT is breezy. Quickly we'll do it. What does she say in her own way? That rhymed. She says, hello, there is pyruvic acid. Yeah, she doesn't even bother to do into 2. Yeah, but you know, everything is into 2. Oh, come on, red is visible. You guys cry for anything, yeah. Into 2. So, pyruvic acid changes into acetyl coenzyme A. This is link reaction. Yeah, she won't tell you, but I'll tell you. So, in link reaction, 2 NADH2 will be formed. Eyes on the screen, no need to look at me. 2 CO2 are formed, coenzyme A is added, pyruvate dehydrogenase complex is involved. मैं तो नहीं बताऊंगी, but ma'am has told you. Acetyl coenzyme A is the entrance substrate. Acetyl coenzyme A combines with the oxaloacetic acid, condensation happens, citrate synthase. Citric acid, the first stable compound is formed. Citric acid will undergo oxidative decarboxylation. See how simple she is kept. No game of isocitrate or anything, but I've still told you just to keep clarity, just to make sense to you. Okay? Alpha ketoglutaric acid, 5 carbon compound. See, oxidative decarboxylation, I formed NADH2. This is one Krebs cycle, I understand. So the first NADH2 will be formed, first CO2 will be formed, but we are very strict about counting the number of molecules. Yeah? There's a reference to that. You got to count. Okay? Then alpha ketoglutaric acid, successive from the theory. NCERT decoding of respiration, either I will do it in a special class or I'll do in the endgame batch. We'll keep a special class, free for everybody on the app. You can follow my profile on the app. You should. You never know when I'll plan the session. Even I don't know. Okay, maybe on Sunday or something, we will do NCERT decoding of respiration. Saucy is thinking, ma'am, I don't know if it will be. Okay, let me not say it. Alright. Then successive into 2. Happy? Then substrate level phosphorylation, she doesn't even care to write ATP. Into 2. Succinic acid to malic acid. Into 2. Malic acid to oxaloacetic acid. Into 2. There you go. Count once again with me. Eyes on the screen. Let's count NADH2. 2, 2, 2 and 2. How many times did I say 2? Now that tells me who all are listening to me. That's why I ask it this way rather than how many NADH2 are formed. Bolo? How many NAD? I said 4 times, so 8 NADH2. Let's count FADH2. Into 2. How many times did I say into 2? How many times? Sometimes I feel it's just my exam, you know. Yeah, it feels like every day feels like an exam here. 1 time. So 2 FADH2. We've done this just a few minutes, 5 minutes ago. Okay, let's count ATP. Into 2. How many times did I say into 2? How many times did I say into 2? Ma'am, red is not visible. Red is not visible, no? Yeah. But you can hear. Anything else you want to count? Yeah, all energy is counted. You want to count CO2s? Into 2. Into 2. How many times did I say into 2? How many times did I say into 2? If you need the break sooner, you answer sooner. 2 times, so 4 CO2. 4 CO2. Where will you find such a nice ma'am, huh? So that you can see. Kind of clear, sort of making sense, Krebs cycle. Every step that I do, every click on the board that I do should make more sense to you. Now, let's solve this question before we take the break for ETC and we will have dinner. Oh, it's 8 o'clock. We started at 5, right? Didn't realize. Pyruvate dehydrogenase activity. Can you tell me the answer to this question, please? Very easy. NEET 2020 question. 2020. Haha. The year of COVID. Paper was easy. Pyruvate dehydrogenase. Look at the enzyme. What do you need out of these? Magnesium. Everybody sure? Magnesium. This is the reaction. This is the NCERT SNP, page number 158. Who will be so nice to give you the page number and the reaction here? Aren't you guys lucky? Would you practice gratitude? This is the best moment. Yeah? Really empowers you. So, this is the reaction we studied here. Coenzyme A, NAD+, pyruvate dehydrogenase complex. Oh ho ho. Do I need to repeat it further? Done. Next question, everybody. The chat box should have a lot of answers here. It's for you, it's for you, it's for you. The 5-carbon compound formed during TC. NEET 2022, one of my favorite years in terms of the botany paper, which was challenging. Don't don't despise me, but I want 2024 to be, botany paper to be moderate to difficult. Enough with the easy paper, yeah. I work really hard to train you guys. Alpha ketoglutaric acid is the 5 carbon compound. Isn't it? This is the first decarboxylation, isn't it? Alpha ketoglutaric acid. Let's go further. Next question, NEET 2022 again. Bolo. I love this question here. Many people went wrong with this. So, you know, I don't talk to students on the day of the exam. So 5th of May, you will not find me anywhere. 6th of May, we will talk. I go underground, absolutely. Bolo? The number of times, see, if you were thinking ma'am is going outside beyond NCERT, this ma'am is troubling us, other teachers teach only from NCERT, I've done nothing. I did not do any intermediate steps, but I took isocitrate because if he can ask in 2022, he can ask in 2024 also. And from isocitrate to oxalosuccinate, if you remember the cycle, I form NADH2. So, after isocitrate, let's make it an opportunity. There we go. Look at this cycle. He said, how many times carbon dioxide is lost? Eyes on the screen. After isocitrate only here, first decarboxylation is happening, second decarboxylation is happening. After succinyl coenzyme A, I don't need decarboxylation, do I? Do I? No. So, 2 decarboxylations happen after succinic acid. Yay or nay? If you have any doubt, let me know. So, 2 decarboxylations will happen. There is the energetics I was looking for. We have already discussed the energetics. Now, in the break, before I said it, my heart is laughing. You guys should revise in the break while having your dinner. You guys should revise the energetics of Krebs cycle and glycolysis. You know why? I don't want to trouble you. I don't want to take your dinner break and your very busy schedule of chatting and spamming and talking to each other. I don't want to disturb you guys, but you will not understand ETS, the next part of the lecture, which is the most troubling part of this chapter. Most troubling. But today you will see it happening like nowhere. I'm claiming it for a reason. I've put many hours on it to make it easy for you. Okay, and you will write with me. So ETC is happening only on this channel, only with me. Okay, and you will not find that ETC happening anywhere else. Leave the textbook. Textbook is anyway very confusing for ETC. The only attempt that I'm going to make today is that nobody ever finds a problem in understanding ETC, because I know the pain. I've been the student. Okay, so we'll do it post break, but you will not understand it quite well if you don't know the energetics of Krebs and glycolysis. So kindly find some time to do that. When should we meet? How many minutes do you want? For the love of botany. What is the time? It's 8:12. 30 minutes are enough. Eat light food. We will have, what do we have? We have ETC, we have Anaerobic. It could take 2 hours knowing myself. I'm going to go very slow in ETC. So if somebody is looking for a hurried explanation of ETC, there are many classes out there on YouTube taught by many fabulous teachers. You can attend that, but I am going to go slow and I am going to just make you chew every part of it, digest it right now. Because I have heard many cries regarding ETC. So, 2 more hours after the break. Let's meet at, bolo time, Shraddha? No. You know, last I checked, I don't run on a battery. I tried to, but they just didn't give me. Okay, the lady has said it. Let's meet at 8. But why did you say that? Let's meet at 8:46. Okay, thank you very much. Bye-bye. And see if your heart pulls you back to ETS. If it doesn't, it doesn't. That's also okay. Good, no? we are back. I am late. Usually I'm not. Just lost track of time here. I was planning for a few things to do with you. There could be a rescheduling of tomorrow's class as something urgent has come up. There's a meeting. Okay. Tomorrow's Endgame class. Endgame students, give me a shout out here. You guys have been waiting for botany class. I'll definitely take a class tomorrow, even if it's at 10 p.m. Although I don't like late night classes anymore. Doesn't serve my health, you know. I have lost a lot of health in the last 4-5 months here. I just realized it recently. Lot of health means lot of health. And if I don't change my ways, I would regret later. So, no late night classes of botany. Are you mic now? Okay, chat box. Where is my chat box? I'm missing you guys. Oh, yeah. Chiku, late to the class, as always. Astha, darling, good to see you. What are you doing here? Are you the same Astha? My old student, very old student, very, very old. Did you guys, Akshita, not cool at all. I am not talking to you. See, I can't keep forgiving everything here. You guys take it for granted. If you would have met me in an offline class, you would be in a different state. I was called the strictest teacher in my offline classes. But that's now an old story. Since 2018, it's been the camera and I. Okay, Akshita, but you know, I don't come here every day. I am not at all strict. If strict was sitting somewhere, he would have the biggest laugh of his life for saying that I am strict. I am the most, in fact, I don't believe myself. Who is this person? I think discipline is the first thing that should be applied in learning. Anything means anything you're learning in life. So, I wanted to be more strict. Don't talk about your personal experiences. My interaction with each and every one is different. Every student is different, and the way I push you in your life will depend on where I see you in a few months. So, you can't see yourself from my eyes. Shraddha? Why do you make me so angry? Alright people, get back to the class. We are going to talk about something serious. What all do you do? Oh God. Did you guys eat well? I had some food. That is also something I need to take care of here. What have I done? Ma'am, missed you in the new series live event. Which live event new series are you talking about? Oh, you had coffee and boiled egg? Please don't do that. I have learnt it the hard way. You don't want to be perpetually sick. Okay, khichdi is fine. Alright people. Eat healthy, sleep well, and taking care of your health is very important. Really, really important. Chalo, let's go further. We did all these questions now. Where are we headed? We are headed at something that you usually don't hear because everybody calls it ETC. So today we'll do something different. Ready? Now, one of the electron transport chain is a very generic term. that I heard it so nicely from ma'am's mouths. In photosynthesis, if I try to derive the meaning of etc, everything is fine, right? Oh, okay. No problem here. It's enough that ma'am is going to teach you. Yeah, anybody can announce the series, that's okay. I was traveling. Okay, chalo. So ETC is electron transport chain, isn't it? In light reaction, the Z scheme that we studied together was all about electron transport chain. What is electron transport chain? Well, my cell, the respective organelle, in that case, it was the thylakoid membrane here. It was the thylakoid membrane. Okay, it has proteins, protein complexes, cytochromes. If you remember iron, sulfur, ferredoxin, answers in the chat box. Who were the electron carriers in ETS and chloroplast? Even if you don't know about mitochondrial ETS, they were iron sulfur proteins, there were ferredoxin, there was pheophytin, there was plastoquinone, because it's my exam on 5th of Feb. Yeah. All these were arranged in a series of redox potential, which is simply my want or desire for electron. My electron moved. Remember how many times I said it, you guys were like, oh my god, we can't hear this enough. The electron is moving up the redox potential. The next protein complex has more desire, yeah, of accepting the electron, if to put it in very, very simple terms. And then as a result of this, whenever this happened, I saw that the lumen, remember I became the lumen. I was the bad guy, I was greedy. You guys were the stroma, the nice guy who's giving protons. Ultimately, he became deficient. He acquired an alkaline nature, and I, the lumen, became acidic. So, this further told ATPase or the coupling factor or the F1, F0 particle to balance this out. And that was our popular chemiosmotic hypothesis. We call this ATP formation. Electron transport is the driving factor. It is causing this disbalance, because whenever I am transferring the negative charge, yeah, I am extracting positive charge from the stroma part, right? So, but the resultant ATP formation was called as photophosphorylation, because this was happening. Electrons, remember, photosystems were the ones giving out electrons in the outer orbitals, if you remember from that class. If you haven't watched that lecture, go into the playlist. It's so well structured. It's a library of all the lectures we've completed. We've completed entire class 11s. Yeah, starting from the very first lecture of sexual reproduction in flowering plants. I've done it all. So watch that lecture. You'll get this information. You will apply all that knowledge. But the defining feature or the characteristic feature of mitochondrial ETS is actually terminal oxidation. Okay? So yes, I agree that ATP will be formed. It won't be in the presence of light. Yes, electron transport chain will happen, but the carriers will be different, although their composition is pretty much the same. What is so special is, your NCERT says this so beautifully. She's a wonderful book. That you might wonder, we've been singing this song since the starting of the class, since the topic started. Oh, aerobic respiration requires oxygen. It's the oxidative breakdown. In glycolysis, no oxygen. In Krebs cycle, did you see oxygen anywhere? Since oxygen comes into play in the end of it all, I use the term terminal oxidation. Not only that, this, what you're going to see, is a series of oxidation reduction reactions which are going to cause the formation of ATP. I'm going to repeat this because it didn't get into your head. I know it. In photosynthesis, light was the driving factor here. If I received 680 nanometer or 700 nanometer for PS2 and PS1 respectively, I did what I'm good at. Shoot the electrons out. Okay? But here ATP will be formed as a result of oxidation of reduced coenzymes that you, the cell, made during glycolysis and Krebs cycle, before you had food, pre-break. We made so many NADH2, la la la, we've been singing energetics whole evening. But the utilizable form of energy, na baba, the currency has to be ATP. So NADH2, FADH2, however fancy they are, yes, very nice. They have to ultimately donate, contribute all their reducing power to form ATP. If I have to give you an example, yeah, let's say you have a lot of money right now, yeah. Now lot of could be very, whatever seems lot to you. It can be 10 rupees, 100 rupees, 100 crores, whatever it is, yeah, each to his own. And you are thinking, no, I am a rich man or a woman right now. I am going to travel and go to wherever you want to go to. I want to go to, now that's not me, I don't want that, but yeah, let's say you want to go to California. Like, I want to travel the world. I will travel to California. I'll enjoy. I'll have the time of my life, or I'll go to Spain, or wherever. And you carry those 100 crores, 100 rupees, 10,000 rupees as it is, and go to that country. Your value that time, money wise, is zero. Why? Because your currency is not utilizable in that country. You would have to convert the Indian rupees into the US dollars. Isn't it? And perhaps Shraddha, Sausi, Mayuk invite and take poor old Pankhuri ma'am on the trip. Poor ma'am is teaching us since years and years. She doesn't have the currency. In rupees or dollars, might as well help her out. Isn't it? So that's what is happening. NADH2 and FADH2, as nice and as good they are, thank you very much, they will have to convert themselves into ATP. That means if NADH2 is losing out hydrogen and changing back to NAD+, and that is also necessary for the continuity of the Krebs cycle, na baba? I need NAD+ back into the mitochondrial matrix so that I can convert it into NADH2. This is called as oxidation. Yes? So, what is terminal oxidation? Terminal oxidation simply means electron transport chain. Yes? This is a part of it. And there is another phenomenon that's happening, which is oxidative. See, I can directly write the terms. You can take it down in the notes. Textbooks are full with terms. But if the term does not make sense to you and you're mugging it up, if you're mugging oxidative decarboxylation, oxidative phosphorylation, terminal oxidation, then take it from me. you're going to be inaccurate. You're inviting negative marking in your life. Don't cry later. So now you know why I can use the term oxidative phosphorylation. You know, I receive messages, ma'am, please get water in the break. Yeah, I'm blessed that way with all the love. But I didn't get water. Like I said, I lost track of time. Boys and girls, while these two processes happen, electron transport chain will lead to formation of metabolic water. The water molecule which is formed in mitochondria, in the inner mitochondrial membrane or cristae. What is the site of terminal oxidation? We've been talking about it all evening. Remember? Cristae. Yes, I will form metabolic water, and oxidative phosphorylation will form ATP, formation of ATP. Well, that's what I have been seeking. You promised me that water will be formed. In fact, ecology, which we are going to start from next week, 14th of February, like I announced in the evening earlier. In the first chapter itself, organism and population, we study a little bit about the xerophytic adaptations. So if you remember kangaroo rat, that's a very popular question from that chapter. Kangaroo rat, which lives in absolute deserts, has to use this metabolic water. It cannot have access to outside water for days together, Sahara desert and all. So whatever water the mitochondria or the cellular respiration is making, poor guy has to live on that. Solid urine, that is the question. Is this very, very clear to everybody? Now, for this purpose, if I am forming ATP in cristae, just the way thylakoid membrane had electron carriers, I would have, I means who am I today? Cristae. I have become cristae now. Cristae has protein complexes. You will be very happy to know, when I say protein complexes, they consist of, they are very similar. Okay, they consist of FeS, iron sulfur, they consist of, not ferrodoxin in this case, cytochromes, lot of cytochromes, more amount of cytochromes, and lot of cofactors. Lot of cofactors here. Now here the complexes are taken seriously. This is all bundled up together in the form of complexes here, which we are going to speak about the next. Remember that oxidative phosphorylation is also going to follow the chemiosmotic hypothesis or the Mitchell's hypothesis. Did Mitchell get a Nobel Prize? I wonder. Did he? 1978? Just check it out. I get excited. 1978 is so recent. Our parents were there. My parents were there. So chemiosmotic hypothesis or Mitchell's hypothesis said in the last class only, ma'am, that in order to form ATP, no matter what are the requirements? 3 points given in NCERT here. What were the 3 requirements? Answers in the chat box. Exam is yours. I mean, it's your exam. I need a selectively permeable membrane, yes or no? There it was thylakoid membrane, here it is inner membrane, inner mitochondrial membrane. What else do I need here? I need electron, I need proton gradient. This is very simple. You guys are good at chemistry. Can we call it electrochemical? Because negative charge and positive charge, it's the dance of that. So can I call it electrochemical? Does it seem fearful to you? Potential gradient. Potential gradient. Or I call it PMF, proton motive force. This is going to, this gradient or difference between 2 spaces is going to activate our F0, F1 Fernandez-Moran particle. Without that, nakko, not happening. And needless to mention, all of this will be in vain if I don't have the coupling factor. Agree, ma'am? You are right. We did this in last class. We don't remember anything. If you remember, very good. If you don't, that's what I'm doing. Taking care of the ones who don't. Agreed? So this will be applicable. Now I am going to do ETC in a certain way. Ready? We are going to go Picasso. We are going to go Picasso. If you remember, I drew the thylakoid membrane. I enlarged thylakoid membrane. Yes? Today I am going to show you the bigger version of crystal. What I am going to do is, I am going to take mitochondria. Kahan gaya mitochondria? Ye raha. This is mitochondria. I am going to take this guy and I am going to smoothen out, iron out the foldings. Spread it out, the blanket. And I am going to show you how it's done. So, might as well draw with me. Yes, this is your inner mitochondrial membrane. What lies on both sides of inner mitochondrial membrane? On one side, I am enclosing the matrix. Baba, gradient has to be formed between 2 spaces now. In case of chloroplast, what did I do? I created the proton motive force between I, the lumen, and you, the stroma. Same thing, equate it. Equate it. So, matrix. इतना काम मत करवाओ. अबे. Matrix. Good. Equated to stroma, and lumen will be equated to PMS. What is PMS here? Anybody? I said in the early evening, what is PMS? Okay. Why do I ever see the chat box here? Okay, perimitochondrial space or inner mitochondrial space. Now what we are going to do is, we are going to do wonderful things in life here. Let's tweak it a little bit. I like to tweak. Otherwise it gets boring. Nice. What did I just do? No clue. And we will go a little nicely. What do you think? Can we do that? Right? What did I do? No clue. Not supposed to have a clue every time. Don't look for clues. Mazedar. Okay? Yes? Now something else is going to happen. Acha. Let's go. Very good. Makes sense. ठीक है. Now let's go this way. Makes sense to me. No. Let's go create a little gap, and yeah, this is my favorite. What did I just do? Who knows? More time to chat. Maza aa gaya. And now my favorite. ठीक है ना? Okay. Okay. And let's do this way. And this you guys can guess. I'm sure you guys are very wise. Nice. Okay. Yeah. I don't mind doing this. I don't mind. Okay. Yeah. Pretty. Me happy. This you guys can guess it out, no? Wow, so yummy. Find out anywhere on YouTube if somebody will teach you ETC like this, and let me know. And I'm not saying that I'm the best, I'm teaching. No, everybody's working really hard, but everybody has a certain pace and way of explaining the same concept. Anybody can suit you, but the idea is to innovate. Okay, we went all Picasso, we are wonderful. Now what we are going to do, in order to make sense out of this, we are going to go leave it for some time. What we are going to do, we are going to leave it for some time. Enjoyed? This much is clear that inner mitochondrial membrane has something happening here. Now you guys know that inner mitochondrial membrane has complexes. That's what has happened here, right? And on one side she has matrix to talk to, and on the other side she has PMS to talk to. So let's give them names here. Serious. So the heading is complexes of ETC. I'm serious about this heading. I'm very serious about this heading, and you will know why. So the first one, boys and girls, is complex 1. And answers in the chat box. What is the name of complex 1? It is NADH dehydrogenase. You have spent a lot of time with me in the evening, and I've been giving you this trick. What did I say about dehydrogenase? Let me see who's answering in the chat box. What do you understand by dehydrogenase? I don't want the day to come wherein I have to block people. I have too much of patience for that, but let's see. Ma'am, please speak Tamil. I said in the evening that whenever you see dehydrogenase, there is removal of hydrogen. Okay, so that gives you an idea. This complex has two components. FMN. What is FMN? You have studied that in the evening. And FES. That is iron sulfur protein. Let's talk about complex 2. Since you guys are paying so much of attention, might as well. Complex 2. FADH dehydrogenase is a simple FADH2, okay, you can name it, keep it simple, dehydrogenase. I am going to nickname it. I haven't. So somewhere you will see authors mentioning succinate dehydrogenase. Why? How can they do this? Answers in the chat box. This has a component called iron sulfur protein. Now, if you want to understand ETC as is given in NCERT, I am not going beyond NCERT. If you are thinking, oh, ma'am is going beyond NCERT. Is this clear? So, dehydrogenase succinate, because you remember that FADH2 was formed when succinic acid changed into fumaric acid. That time FADH2 was formed and the enzyme was very special membrane bound enzyme called as succinate dehydrogenase. Is this clear? So don't get affected if you see the different name. Is this clear? Then what is happening? The third complex will happen. Let's talk about the third complex. Now, I have been saying dehydrogenase. Yes, that means FADH2 will get oxidized and NADH2 will get oxidized. That is the purpose of ETC. Oxidation of, you are changing the currency to keep being rich on other parts of the world, and FADH2. Yeah, these are the three forms of energy. Complex 3 is a serious complex. Not that these two were involved in any stand-up comedy, but yeah, serious in the sense. The name of the complex is cytochrome. Cytochrome BC1 complex. As the name suggests, it has three components rather. It has the cytochrome B, it has FES, and it has cytochrome C1. Happy? Healthy? Don't give up. I'm doing it very slowly, starting from absolute easy peasy basic things. Then comes complex 4. Complex 4 is cytochrome C oxidase complex. Are we happy? Okay, and it has 3 components. Okay, if you are guessing it is cytochrome C, no. It has cytochrome A, cytochrome A3, and 2 copper centers. This has been given a lot of importance in the recent years. The presence of 2 copper centers in complex 4, and that's about it. These are the complexes, 4 complexes of ETC. I know 90% of the people will add complex 5 here. Okay, before I go to that concept, this is not all. These complexes are facilitated by integral proteins. No clue. If you remember the structure of cell, we know that we have peripheral proteins and integral proteins. Peripheral proteins lie on the surface of the membrane. Here we are talking about inner membrane. Integral proteins are embedded in the membrane. Then there are transmembrane proteins which help in the transfer of substances. Yeah, so transmembrane will go through the membrane. Yeah, it can create a connect between the matrix as well as the PMS. There you go. If my protein is traversing, I have not made it very transmembrane, but if it is traversing between matrix and PMS, I can connect, I can pass things from matrix to PMS. But if I am located integrally, look at this, not this, look at these two, then I cannot. That is an integral protein. Look at this one. These are absolute basics of biology. Look at this one. This is absolutely outside the membrane, on the surface of the membrane. Peripheral protein. You will see these terms in NCERT. Never focused before, but now you will. So we are done with 4 complexes. Now complex 1 and complex 2. Complex 1 and complex 2 connect to a certain molecule, certain cytochrome like substance. Let's mark it as star 1, and between complex 3 and 4, I am very categoric about this. Listen to me carefully. I didn't say star 1 molecule is present between complex 1 and 2. That is also said at many places. It's not correct. Complex 1 and complex 2 are connected to star 1. Between complex 3 and 4, okay, is present star 2. What is happening? So we'll find some place here and we'll take care of these two, as we always do. So these are something called as mobile carriers. These are also proteins here. Why mobile? The other things you saw in the painting or these complexes are studded. They cannot move. Star 1 and star 2 have the liberty to dance in the membrane. But if you remember the fluid mosaic model, they cannot do flip-flop movement. They can only move laterally. Hence called as mobile carriers. Star 1 is ubiquinone. Okay, designated as UQ popularly. Quinone. Does it remind you of somebody? Something from photosynthesis? Some quinone? I don't want to see the chat box here. Equate it. And cytochrome C. Another mobile carrier. You see cytochrome C oxidase, it is not a part here. And in cytochrome BC1 also I don't see cytochrome C. Ma'am, if this is the case, it is present between 3 and 4. Ma'am, why did you call this complex as cytochrome C oxidase? So if the examiner ever gives a paper, I haven't seen this question, but for the totality of knowledge, theoretically cytochrome C that you see here, mobile carrier, is considered more family with complex 4. It is considered as a part of complex 4. How do you remember? The final interaction of this guy, star 2, is with complex 4. It will also make sense as we go further. This, what I have just written here, all the scribbling, since I love scribbling, that I have done here is extremely important to go back to this. Otherwise, it will not happen. So the problem with people not understanding ETC worldwide is they immediately jump to this, the mechanics of it. You can't do that. Okay? Ready? Now we are going to start the game. Start the game. My major hero of the story today is whom? There are some nice souls sitting since early evening, 5 p.m. They would know I've been singing this. Who is the hero of the story? Not the star. Yeah, who's doing all the appearing for the entire movie? NADH. Who said NADP? Who said NADP? Okay, I don't care. Laharika, it is NADH2. Very good. So now he is formed in the maximum amount. He is the first one to give away all the wealth. He says, fine, I am showing for one molecule of NADH2. This NADH2 will get, eyes on the screen, my voice is enough, will get oxidized to NAD+. I get positive charge, negative charge. I said electrochemical gradient. The 2 electrons will go to the first component, which is FMN. You just saw that here, which is FMN. Who is the next component? FES. So I go to FES. The 2 electrons go to FES. And the acceptor, this is your complex 1 if you are wondering. This is star 1 that we just spoke about. He is nothing. Oh God, you have not let me. Okay, pink is allowed now. This is ubiquinone. He will receive the electrons to himself. 2 electrons. But people, if NADH2 is giving 2 electrons, protons are also formed here. What do I do with the protons? Gaya kya? Nahin. What do I do with the protons here? I will put this guy, PMS, is greedy guy, just like lumen. Give me protons, give me, I will accumulate all the protons. Yippee! He thinks he can. That's the thing. So now, the 2 protons will be pumped right here. First step will go slow, will go nice. There is, even if I have to spend the entire night to tell you electron transport system, it's okay, but we have to do it today. So don't hurry up. And if you think you know everything, then also don't hurry up. You'll only get to know something more. Okay? So 2 protons are pumped out. Is this step clear? This guy is a mobile carrier. I told you. Just like plastoquinone, who was so pavam, remember the story of plastoquinone, who thought that I have the negative charge and I can be happy forever if somebody could give me positive charge and I get stabilized forever. This guy is similar to plastoquinone. So he tells the matrix, kindly give me 2 protons. I am making matrix deficient of 2 protons. Matrix is a nice guy, he never says no. And PMS is the greedy guy. Alright? So this ubiquinone now changes into ubiquinol. Not teaching you outside NCERT, not fond of. Alright? So what we are going to do is, we are going to make this very clear. We know UQ stands for ubiquinone. UQH2, just like plastoquinol. Everything is visible, don't cry. All the Facebook, Instagram and whatever social media you are on, everything suddenly becomes visible there. But when my ma'am is writing in the class, don't use this color, don't use that color. Don't do that. So, ubiquinol. This is clear? Now, I think something has happened to the mic. I'm sure you guys are screaming out there. My life is about balancing the mic and my hair. Something has happened to the voice. Could you hear me out? Yeah, as the night progresses, the chat box becomes more and more horrendous, for the lack of better word. Mayuk, God bless you, बच्चे. खुश रहो. गड़बड़ें होती रहती हैं, फिर भी खुश रहो. All clear? ठीक है. Now, these 2 electrons, this is complex 1, this is complex 2, if you don't know. Let's write it faintly. This is complex 1. I just don't want to make it a cluttered diagram. This is your complex 3. What is the name of complex 3? Answers in the chat box for your own good. I don't get anything out of it. It is BC1. These are all questions. So this guy ultimately realizes nothing is mine. What am I doing? So he has to give the 2 electrons to first, the sequence is, let's make it this way. He gives the electron first to cytochrome B, then FES, then cytochrome C1. Sequence is important. There you go. If it's too much for you. Cytochrome BC1, cytochrome B, FES, cytochrome C1. Okay, ma'am, if you say so. Alright? At this point of time, what will happen to the protons? When this guy realizes the reality of life, I have to give away everything. What am I crying for? The protons, the positive charge also is given up. Nobody is going to keep protons. So they are also pumped down. This complex, third complex, is like, what do we do with the protons? We are wise. We are not like ubiquinone. We know protons is not mine. My role is just to transfer. I am very clear. So this PMS, who's a fool, gets greedy again. Give me the protons. I will be wealthy. So once again, you see 2 protons pumped down into the PMS. Remember, I am adding acidity, positive charge, however you want to see it. Now, this is star 2. What do you want me to write for star 2? Answers in the chat box. I don't want to get angry here. Cytochrome C. You know why I have made it like this? In fact, all this drawing I did and took some time, because when you read the text of NCERT regarding ETC, it is the worst thing that can happen to anybody. And I support you. I understand. There's a line which says that cytochrome C is a mobile carrier and located on outer surface of the inner membrane. Yes, anybody who can write the page number? Just to show you that this is located on the outside surface, sort of close to PMS. Perhaps for the easier transfer. Okay? This cytochrome C will move laterally only. No flip-flop movement is allowed, because that will disturb everything. And I am just the courier boy. I just have to transfer the electron. So these 2 electrons will go to cytochrome C. Don't miss him. Because they are planted in their locations, yeah. This complex cannot jump and ask for electrons from complex 3. Okay? So complex 4 is what? Cytochrome C. Right? So electrons will now go to first cytochrome A, cytochrome A3 and the copper centers. A beautiful thing happens here. First of all, I am going to pump the positive charge out, because this complex is also very wise. It knows that everything is transient. It pumps out the 2 protons. This guy is greedy. Now A3 sees nobody around him. By the way, did you notice did you notice that I did not write complex 5 in this series? And I said 90% of the people write complex 5 in this sequence. I do not agree. Strongly disagree. If I am pinpointedly speaking about electron transport chain, then complex 5 is not a part of it. Because complex 5, boys and girls, is just for oxidative phosphorylation. It is not a part of ETC. Kindly, you can say that it is a part of terminal oxidation. Cannot say it is a part of electron transport chain. If that would have been the case, I could have easily given my electrons. Complex 4 could have easily given the electrons to this guy. Are you kidding me? This guy is like, are you kidding me? I need water, yeah. So, let's write it. It's better to write than regret later. Complex 5 is ATP synthase complex, and it will cause oxidative phosphorylation. Alright, now let's get back to where we were. These electrons, color ही नहीं है जिंदगी के अंदर. These electrons, the 2 electrons which came to cytochrome A3, will now go to the matrix. Okay, and A3 will call out oxygen, but just half the molecule of oxygen. It will give 2 electrons to half the molecule. Something similar you saw makes me so happy in photolysis of water. Did you? Photolysis of water? Don't want to even ask. Major heartbreak I'll have if you guys are not able to answer. Now, oxygen is like, yeah, what do you want me to do? Finally, we've been calling out oxygen, oxygen, oxygen. Remember, terminal oxidation. The final acceptor of electrons is oxygen. This oxygen says, give me positive charge. Yeah? She's like, hey, A3, could you give me some negative, positive charge? A3 is like, yeah, you know, none of us have positive charge because this guy, PMS, just takes away all the positive charge. He's quite a sucker for positive charge. So then oxygen calls out to matrix, you are the nice one, give me some positive charge so that I can make one molecule of water. So now I get, this is how, boys and girls, I get metabolic water. Finally, the entire class has been about this. Is that clear? So, questions like these can be asked. That which cytochrome, listen to my question carefully, which cytochrome or which complex is associated with terminal oxidation or formation of metabolic water or interaction with oxygen. So, if he is asking which cytochrome, you have to be very specific, cytochrome A3. This question has come many times. If I am the examiner, I would put it any day. Which complex is associated? Complex is a complex of cytochromes, na baba. Then it is complex 4. Make sense? So, you will have to revise this again and again. Poor guy matrix has given up on protons. this side of the membrane becomes negative, more alkaline. This guy, there's an electrochemical gradient which is created. I am more positive, I am more negative. And as this, let me tell you, what you're studying is not how things happen actually. This complex is not located at the last. This is just to explain you. This complex works simultaneously in the entire ETC. Nevertheless, now I am going to create balance again. How? I am going to, let's create balance again. These hydrogen are going to move across, NCERT says, down the electrochemical gradient. What does that tell you? Come on, we are studying chemiosmosis. Osmosis happens from high concentration to low concentration, ma'am. Well, it is always across the gradient. People, so it will enter, what is this? Once again, my tennis racket is the best thing ever. This located, embedded in the inner membrane is the F0. So they enter the F0, alright, and go out like this. But when they enter the F0, this F1, I had the ball last time, don't have that. Okay. If I move the stalk, the tail, the head will move. In chemical terms, this is the head or the F1. It is protein. It is ATP synthase. And proteins are sensitive. When I disturb the F0, F1 sees a conformational change. You know how proteins are always crying about their structure. If you've seen a glass door, now they are in India. How many of us have seen glass doors in malls or I don't know. Have you seen a glass door? Yeah, you enter through one side of the glass door. Okay, this is how the glass door is. But as you enter, you just go out on the other side here. But as the proton enters and goes on the other side now, this ATP synthase sees a change and gets activated, if you will. And it will cause this. I told ATP synthase is coupling factor. It is causing coupling of ADP plus inorganic phosphate into making ATP. Finally, yellow. Is this visible? What do I see on the screen? I see one, repeat after me, one NADH. For one molecule of NADH, I used 4 complexes, ma'am. I used 4 complexes to give 2 and 2, 4, 6 protons. To give out 6 protons. Clear? This is all you have to study at this point of time. Remember, a concept is never difficult. It is how you approach the concept. Don't blame the concept. Associate with the right teacher. Be patient. Don't carry this chahiye hi chahiye, abhi ke abhi samajh aana chahiye. I have to understand it in one go. That is when your brain rejects the concept. It's a tendency. Is that clear? This much is clear? Let's take a breather. I'm not giving a break. The breather is, let's talk about this complex more. Yeah? So, in this complex, you clearly saw that there are two parts. The F0 part is the, you call it as the head, you call it as the tail or the stalk. It is just a passage or a carrier for protons, because rest of the membrane doesn't allow, is impermeable to protons. So passage for the bindi is sometimes, for the love of bindi, I know some of you are smiling. Passage for protons. It also serves as a motor. It is the motor which will run and sends the protons across. It is the passage which will disturb the head, moving through the revolving door. What all I do to explain. So this is also called as the smallest biological motor, if you didn't know. It is interesting to me, so I told you. Then comes the F1 part, which is the head piece or the catalytic piece or the coupling factor, just to keep you safe, and it will have the catalytic activity owing to ATP synthase for coupling reaction of ADP plus inorganic phosphate into ATP. Happy? This is what it is. Simple. We are not done with ETC. Good news. Let me see what you guys are up to. Of course. मैम क्या टॉपिक पढ़ा रही हो? भगवद गीता 10th chapter. I like the innovation on the spamming part, not bad at all. My laptop is flickering here. Please don't give up on me. I have classes to take. Okay. All right. Thank you for such intelligent and relevant messages. Let's go here. I just showed you the ETC for one molecule of NADH2. I am not happy. I am not happy because I am yet to oxidize FADH2. Now, the truth of the hour is that ubiquinone will connect with either one of them at a time. Did you hear what I said? Ubiquinone would either receive electrons from NADH2 and it will do its job. Yeah? This courier boy says let's say you guys want to send me a gift. Anything. And yeah, for example, Shraddha is there. Shraddha is in Delhi. You want to send me a gift? Ubiquinone, the courier boy says, fine, I will carry the gift from Delhi. Now, Laharika wants to send me a gift. Tell me the place, yaar. Where do you want to send the gift from? Come on. Just send me the gift. That's all that matters. बोलो. कुछ भी. North Bengal, AP, Andhra. Anything else? Tell me more. You guys are not helping. Okay, Laharika wants to send me the gift from Andhra. So Ubiquinone says, I'm very clear. Either I will take the gift from Shraddha from Delhi and I will deliver it to Bangalore to ma'am, or I can go to Andhra Pradesh and get the gift delivered. Is that clear? One at a time. So UQ, what we are going to do is, for the purpose of clarity, do you want me to rub this out? Anyways, you're not getting the notes after the class. I'm not happy with you people. Yeah. So this guys this NADH2 goes out of the picture. Now this complex 2 here does this. Does what? This. FADH2 realizes my time has come. Gives the electron. Now go back to what I taught you. Complex 2 is FADH dehydrogenase, succinate dehydrogenase. What are the components? Only one cute FES. No complication at all. Don't we love that? So these 2 electrons, boys and girls, will go to FES, and from here they will go to ubiquinone. Boys and girls, time to pay attention on the screen, because the book is not explaining why FADH2 makes only 2 ATP molecules. Time to look at the screen. This protein is an integral protein. You with me? Don't look at me, look at what I am pointing at. This is an integral protein. It is not transmembrane. It is not transmembrane. It is not transmembrane. It will not be able to pump the protons out. Rest of it remains the same. So ubiquinone will have to carry but there will be no pooling of protons either. Ubiquinone will get reduced, finally realizes his mistake, he will use these protons. As simple as that, yaar. No, nothing is getting pooled up anywhere. So FADH2 breaks off to give 2 electrons and 2 protons. Goes to ubiquinone. Ubiquinone is happy. Becomes UQH2, ubiquinol. Soon realizes nothing is mine. Goes to complex 3. Yes, it will have to. These are wise complexes, as I told you. They will give the protons. Give the protons. Give the protons. How many protons did I get for one FADH2? What do you see on the screen? How many protons did you see? कुछ नहीं हो सकता यार. Oh God. Thank you. 4 protons. Ma'am, we still don't have the answer that why one FADH2 is making 2 ATP and NADH2 is making 3 ATP. I don't know. I told you not to jump to concepts before you understand the basics. For now, what you will remember is just this. We are going to, as was the promise, we are going to talk about the energetics now. In the evening itself, when I started the class, I said every step we will discuss the energetics. That's a promise. I am not doing balance sheet of respiration till I do energetics. Usually energetics of ETC is not really done, but we'll do it in our own way. and after that we will solve many questions of ETC. So now I realize that for one molecule, for one NADH, I pump out 6 protons, and the rule is that for one ATP to be formed, 2 protons are required. This is the rule, you can't break it. See, that's what we did here, yeah? This one. If I want to make one ATP, I got to give 2 protons. 2 electrons, 2 protons. Mazidar. Yeah? So, this clearly tells me that for one NADH2, I would easily form 3 ATP molecules. Very happy life. No problem at all. Let's talk further. For one FADH2, how many protons were pumped out? 4 protons were pumped out here. If for one ATP I want 2 protons, how many protons will how many ATP will FADH form? Quickly guys, before we move on to balance sheet. If you want to be free from this, you got to answer at least the serious ones. Whoever you are, Arun, I'm not talking about that. Two ATP will be formed. Boys and girls, I've been receiving a lot of texts about the various videos doing the rounds about the modern concept, which is given in new NCERT, about the whole confusion about how many ATP are formed by one NADH2. I don't remember the name. Yeah, whoever has texted, I thought I'll reply it in the class. And one FADH2 forming 1.5 ATP. This is incorrect for sure. That is also partly correct. Okay. Today I am going to take care of the confusion once for all. If it is asked in the exam, you will give preference to the conventional concept. I know that's not what you hear on YouTube. Yes. The examiner is not going to put a contradictory question. I am not expecting that he will put 2.5 and 3 together in one question amongst choices. Either your correct answer is going to be 2.5 or 3. Point number 1. The reality of the NCERT is that you guys have been crying about watching some 10 videos, and that's why those videos are made, because you guys watch it, get distracted, waste your time, then message your teacher, then waste your time thinking why ma'am didn't reply. That is why those videos are made. NCERT has changed the diagram. It has changed the text only for this, and I'll show you right now. But NCERT still says in theory, correct me if I'm wrong, open up your NCERT, what page is it, 161 or something, I don't remember, I'm living with old NCERT. It still says, that is why NCERT can be cruel sometimes. but I am solving it out for you. It says that 1 NADH2 is going to yield 3 ATP, 1 FADH2 is going to yield 2 ATP. Whatever is present in the text holds more value than what is present in the diagram. You will mark this. Second thing, let me discuss the worst case scenario, because you guys imagine that first. I've realized हमारे साथ तो सबसे ही बुरा होगा. Have faith in NTA. Like I said, NTA is on your side. If at all a day comes where 2.5, because you disturbed me, I was explaining the conventional concept, and then you guys try to be smart and put it in the comment section. Now let me clear it. If a day comes when he gives 1.5 and 2 ATP as both in the same question as choices, that question would go for bonus. I promise you, it would go for bonus. First of all, they won't do it. They have brains. They are not selling bananas. So don't imagine the worst case scenario. Done? Okay. The text still says that 38 ATP molecules are formed, and 38 ATP molecules can only be formed. Your new NCERT, very new NCERT, very, very new NCERT, born today, born right now NCERT. Guys, please don't irritate with such texts here. Just because somebody has put some video and they are least informed about it. You will only change your answer and leave the conventional concept if they change it in the text. For example, if tomorrow a question comes, how many protons are required to form 1 ATP? I am very happy to say that you can mark 4 protons, because that is changed in the text. I know, calm your senses, I know diagram, I have the diagram right now. Alright, so what we are going to do is, we are going to stamp it up. If something is troubling you, stamp it up. So, let's write it here. The whole hue and cry on everywhere is the modern concept, which is not modern at all. This is the concept that is studied in higher classes. Modern concept or the new NCERT. Get it out of your system already. It says, point number 1, that 1 NADH2, I am going to write everything here once for all. Don't cry later. 1 NADH2 pumps out 10 protons. It is pumping, I agree, in the diagram. Very beautiful colored diagram NCERT has made. Done? If this is in the choice and 6 is not in the choice, be happy. But if 6 and 10 both are in the choice, that will go for bonus. So this means the second concept is, the modern concept is that 1 ATP, this I changed, 1 ATP, let me change this, requires 4 protons. The whole mechanism you don't have to understand. Why proton is required to transfer the ATP to the matrix part. The whole mechanism is, don't even bother. It will go for a 6er. Now if you equate this, therefore this changes, and what you guys have been so beautifully screaming here in my chat box, I could easily form 2.5 ATP molecules. Happy? ठीक है, हम तो मैम हैप्पी होते ही नहीं हैं. नाउ लेट्स टॉक अबाउट one FADH2 is pumping out 6 protons into PMS. ठीक है, so therefore one FADH2 will give me 1.5 ATP. Happy? I've written it. This part is not told in the theory of new NCERT. And this is how, boys and girls, you do ETC. If you didn't realize, it's done and dusted. Don't tell me you understood everything. Not possible. You'll have to revisit this concept and study again. Is this very, very clear? Let's start solving questions to cement the concept. Okay, okay, yeah, that's. Oh, I have a strong army here. Lots of love from Bangalore. You guys. Okay, so now what we're going to do is we have to, yeah, things are getting serious. Things are getting very serious in the sense that you will have to apply all of this drums and flutes into, I think I have questions. Okay, let's see into balance sheet. Balance sheet of exactly the gain and the loss. The gain. In balance sheet, we talk about the gain. We invested this much. Abhi, how much did we make? That is what we are looking for. I am not bothered about what happened the entire year. At the end of the year, what is the balance sheet? Make sense? So, what we are going to do is we are going to remove the fear of new NCERT from everybody's head. Cool? I've told you what is what. Now, I'm going to, let's see the devil in his own face. Let's clear out NCERT. For that, I badly need water. Would you guys mind? I get some water for myself? Yeah? Out of the class means out of the class. Tyagi. Thank you. Even if you guys mind, I would get water. If this is already present in the human world, but what if there is a pill? You know, you just take the pill and you don't have to drink water. Do you think that is still available? I don't know where the world is going. I don't ever care about the so-called modern concepts we are headed at. Because ultimately, it's of no use. What do you think? That'll be a good idea for such marathon classes? यार ये इतना गड़बड़ है. So let's solve questions while I solve the garbad. Be very careful, huh? ETC means ETC. Oh, before the questions, we have to decode NCERT. Look at this scary diagram. Come on. Don't get scared. They have just updated the concept. See, this is what we did, na? Inner mitochondrial membrane. One side is matrix, another side is PMS or intermembrane space. Eyes on the screen, huh? Then NADH2. Complex 1 is NADH dehydrogenase. Eyes on the screen. Goes to FMN. If you were thinking ma'am is teaching something extra so complicated, she told us complexes and all. See, it is given. I care for you. FMN, FES. Okay? 2 electrons are coming in. No problem? No problem. But pulling out 4 protons. Updated concept, modern concept. Modern concept is 10 protons in total, right? So now, this is your complex 3. From complex 1, I will send the electrons to complex 3 because complex 2 is for FADH2. That is the gift that Laharika is sending from AP. Right? So, complex 3 is cytochrome BC1 complex. See, everything I told you goes to, the electron goes to cytochrome B, then FES, then cytochrome C1. And I am pumping 4 protons. Meanwhile, FADH2 tells ubiquinol, hey, what about me? Ubiquinone, I'm sorry. Ubiquinone, what about me? So now, see, they have shown the reaction also. When succinic acid changes into fumaric acid, FADH2 is formed. Yeah? So, FADH2 sends the electron to ubiquinol. Isn't it? And then, again, I interact. Whatever, whether it is complex 1 or complex 2. Complex 3 is going to send the electrons to cytochrome C, who is a mobile carrier. See how nicely NCERT. Beautiful she is. Okay. Shows the mobility, lateral mobility of cytochrome C. Lateral mobility of cytochrome C. Okay. So now I am sending the electrons to complex 4. Who is complex 4 in my life? Eyes on the screen. Cytochrome C oxidase. Because cytochrome C interacts with cytochrome A, cytochrome A1 and copper center. This complex is further pumping out 2 protons. With me? With me? So how many total protons? Let's count for the first one. First complex. Eyes on the screen. Huh? Won't help. Won't help otherwise. 4 and 4 is 8 and 2. 10. The diagram speaks about. Yes. Oh, you've made me so scared of the red color here. 10 protons per NADH. Let's talk about this guy. FADH2. Could be. You will, this will be deleted. This is not happening. This one doesn't pump anything. FADH2 doesn't have the capacity to pump because it's an integral protein. It's not transmembrane. Do you see how beautifully she has shown the transmembrane aspect? Eyes on the diagram. Better if your own new NCERT is open. Is it page number 161? Is it page number 161, everybody? Or 160? I won't remember the pages of new NCERT. It's 160, right? So, If you look at FADH2, he cannot promote. He is not transmembrane protein. These are transmembrane. So I get 4 protons owing to complex 3. I get 4 and here also I get 2. So this diagram proves the modern concept, if it makes you happy for me to say it. So 6 protons per FADH2. ठीक है, cool है, good है. And now lastly what will happen? See, electrochemical gradient. Do you see how, what a beautiful diagram here. I can't stop gushing at it here. And it's only NCERT. See, electrochemical gradient, matrix gets negative charge. Inner mitochondrial membrane, space, the space gets positive charge because he was greedy. So now these protons will move across the gradient from positive to negative. From down the electrochemical gradient, what does this mean? In osmosis, it means from more concentration to less concentration. Something is wrong with my clip here. Huh. You with me? F0 is present in the membrane itself. It is embedded. This is the F1 is the head. ATP synthase, ma'am taught us, and ATP is formed. Look at the A3, look at the complex 4 interacting with the oxygen. Oxygen, 2 protons, electrons kahan hai bhai? Okay, it's still showing 2 protons. Okay, that is something else. Don't get confused with these 2 protons. This is showing just the pumping of protons from matrix to PMS. Yeah, this will combine with 2 electrons. That's understood, to form 1 molecule of water. Diagram is done and dusted. Okay, let's get to the theory part of it, if you're scared. Now I'm going to prove to you why I'm saying what I'm saying, that please follow the tradition. I don't want any more confusions. Don't be scared to text me, that is okay. And some people have been very honest about, ma'am, we are watching so many videos, what is the truth? But make an attempt to be sensible about it. Let's read it together. When the electrons pass from one carrier to another via complex 1 to 4 in the electron transport chain. Just a while back, I told you that in electron transport chain, you will never include complex 5. Here it is. NCERT is God's voice. She says everything, but a little in a coded manner. Okay, so it's good. It's good. So this is what it is. Complex 1 to 4 in electron transport chain, they are coupled to ATP synthase. There you go. Which is complex 5 for the production of ATP from ADP and inorganic phosphate. Okay? The number of ATP molecules synthesized depends on the nature of the electron donor. Who is the electron donor? Who are the possible electron donors? Lost it? Don't know? People, the sensible ones, if I don't come to the chat box at all, kindly understand. Yeah? We'll talk in the endgame batch. Because I don't want to lose my sanity. So, there are 2 kinds of electron donors, na? Either it can be NADH2 or if it can be FADH2. Okay? Oxidate. See? The problem is, because of so much of information out there, I have to prove it to you. Oxidation of one molecule of NADH, she hasn't changed the theory, gives rise to 3 molecules of ATP. Text is important. While that of one molecule of FADH2, before you go all berserk, 2 molecules of ATP. And it feels a little, what does it feel like? Worrisome. I feel worried. Oh, although the aerobic process of respiration takes place only in the presence of oxygen, see, the role of oxygen is limited to the, I've been saying this since evening, since I took birth, feels like that, of the process. We say that aerobic respiration simply means it cannot take place without oxygen here. Everything will stop. But we see her making a star appearance only at the end of it. Okay? Good, good. Now let's talk about, this is I think page 160 or 161 of the new NCERT. I'm going to prove to you why you would mark 4 protons for 1 ATP. Done? Read it out. It's my exam. I will read it out. First, let's look at this here. Let's appreciate the beauty of it. Look at the diagram in your textbook. My voice is enough. Do you see? This is my inner mitochondrial membrane. What does it have? It has the mighty coupling factor, but only the F0 part is embedded in the membrane. Eyes on the screen, going to help you a lot. F0 part is the integral part. Mane, it is inside the membrane. If I look at the head part, it is outside the membrane. That is towards the matrix. Because I want to categorically form ATP in the matrix. Done? We also call it the outer side. What is outer side here? Don't get misguided. Simply means PMS. Done? Let's get to the theory of it. As mentioned earlier, the energy released during the electron transport system is utilized in synthesizing ATP with the help of ATP synthetase. This complex consists of 2 major components, F1 and F0. F1 headpiece, I want you to make a note of that. F1 is the headpiece, is a peripheral. There you go. I sing for a reason. I say for a reason. I repeat things for a reason. I make you write for a reason. I get nothing to do that. Yeah? So make sure that every word that you've heard in today's class carries a lot of coherence with your new or old or whatever NCERT. There you go. Why I have been focusing on a simple term like peripheral? For a reason. So that you read NCERT and it makes super sense to you. Yeah, you are like, wow, now I know what it means. Membrane protein site for synthesis, you know that, okay. F0 is there you go, integral membrane protein complex that forms the channel. We use the term passage through which protons cross the inner membrane. Otherwise, there is no way to cross the protons. Why? Because protons which are pooled here, this membrane is impermeable. She says, no, don't come near me. But this is the channel. The passage of protons through the channel is coupled to the catalytic site of F1 component. This site coupled means, let me decode this word also. Yeah? Like I promised, everything is going to make sense for the first time to even somebody who thinks you're perfect in this chapter. That's how science is. You can never be perfect, even close to perfect. Okay. Coupling means that if proton will pass through F0, it has to cause a conformational change, or to help you understand a sort of a disturbance in the protein ATP synthase present here. Catalytic site. What is the catalytic site? I wrote this word. Catalysis of what and what? Catalysis enzymes are what? They serve as catalysts. Catalysis of ATP formation through ADP and inorganic phosphate. Now, boys and girls, there you go. Let's mark it together. Yeah. L. Good. Let's mark it perfectly. Read for each ATP produced. 4 protons passes through F0. Look, NCERT brings so much of patience in your life, especially if you are a teacher who is passionate about each and every word of this book. Look at this here. In the diagram, it shows 2 protons. You see what is happening? But in the text, she has changed it into 4 protons. Passes through F0 from the intramembrane space to the matrix, down the electrochemical gradient. Every word should be like, yummy. I have not met any student in my 12 years of teaching who has made sense out of every word of this chapter and photosynthesis as well. Okay, so make sure that you do that. Otherwise, these chapters are they will repel you like nobody's business. Yeah, I'm with you. They're not very easy or very palatable or very charming, as you would find perhaps genetics, or it's easy to read morphology also. Human reproduction. Down the electrochemical proton gradient. See, I said electrochemical proton gradient. Down means, what is down? More to less. Because when I go downhill, I don't require energy in my life. That is very ethereal also. Okay, chalo, done. This gives us a good wrap up on, not on the class, a lot is left on the ETC and all the confusions. So if there is a considerable change in the text, then you will change your option. But see how NCERT is. And when this happens, remember my words, NTA is on whose side? Your side. Okay. Now let's talk about the questions. Chalo. Time to stretch my back. Answers in the chat box, everybody. Yeah, I said 2 hours of class, no? We met at 8:50. It's already going to be, okay, it's okay. 1 hour more. Answers in the chat box, everybody. Come on. Everybody is sure? It's 4. Let me read the question. Identify the cytochrome which acts as a mobile carrier for the transfer of electrons between complex 3 and 4. Oh, ma'am went Picasso with this. Huh? We can never be incorrect. So that is your cytochrome C. Any problem anybody is facing? Don't tell me. I have never been able to finish my class on the promised time. I'm so struggling with it. I always think, today I thought it's going to be a 3.5, 4 hour class. I don't know how and when time runs away. Saucy, don't do that, yaar. Oh God. Okay, this is a good question. NEET 2023. I think I should use my chair. She's laughing at me because I'm standing since, I think it's been 6 hours now. Okay, tell me. This is a lovely means lovely question. Lovely. Checks all your concepts. Fatafat. Quick. Oh, come on, I gave side already. You guys throw me out of the screen here whenever you see a question. Crazy. People are saying 2 and 3. Why are you doing this to me? And then deleting your messages. You can't escape from me. So, oxidative decarboxylation, boys and girls. Now, I love saying this, you know. I told you so. I love saying this. Oh. In the evening, I think I screamed so much about, please make sure you know what is oxidative decarboxylation. Please make sure you know what is oxidative phosphorylation. It's not in NCERT. It's not explained anywhere. Why did I do that? For this reason. So that you never go wrong with any MCQ. This is 2023. Oxidative decarboxylation, where does it happen? Series of cyclical process of oxidative decarboxylation is Krebs cycle. Yes, we did that. So what is your answer? Pyruvate dehydrogenase or link reaction. Glycolysis, EMP pathway, Embden-Meyerhof pathway, oxidative phosphorylation. Where will it happen? Electron transport system. Tricarboxylic acid cycle is your citrate synthase. Why? Because I call it tricarboxylate because of citric acid. And for the formation of citric acid, I need citrate synthase. How many of you found this question to be absolutely yummy? Absolutely like, yeah, we could do it easily. See, these kind of questions might take more than 30 seconds in the beginning. But make sure before you go to the exam center, they don't. Can you do that for me? And how will that happen? If you solve more and more questions like this. Next question, everybody. Let's solve this. NEET 2022. If you were thinking I'm just going to let you go, I don't do that. I want chat box to be burning with answers. Even if you're not correct, it's okay. It's good to be wrong. Sanjana is saying 2. When you answer wrong, it really bothers me. So, ETS complex 1 is NADH dehydrogenase. Now, in such questions, I've always taught you the trick, na baba? Elimination, guys. When will you learn? ETS 1 is, acha, wait. Yeah, ETS 1 is NADH dehydrogenase. A goes for third. A goes for third. Eliminate. ETS complex 2 is ubiquinone and FADH2 dehydrogenase. Did you guys get scared of this? My students getting scared of a word. Ubiquinone and FADH2 dehydrogenase. Why not? Because complex 1 and complex 2 both interact with this mobile carrier molecule called ubiquinone. Why can't I call it? I can call it anything. Ubiquinone and FADH2 dehydrogenase. Okay, so B goes for fourth. You eliminate and you get your answer in under 30 seconds. Make sure if you are giving more than 30 seconds to a botany question, it is going to cost you big time for physics, chemistry. Please don't do that, at least in my subjects. In my subject. Right now, at least. ETS complex 3. What if I start teaching physics? ETS complex 3. Now, everything else is sorted. Next question. NEET 2021. Come on, come on, come on. This is the last question. Fast means fast. There is no, we have to do the balance sheet also. And the class will be over by 12. Pakka, it is option 4. Sure. Are you guys? ठीक है, but you have to find the incorrect statement. Remember, you're finding the incorrect statement. ATP is synthesized through complex 5. Oh yeah, very good. Oxidation, yummy, good. During aerobic respiration, the role of oxygen is limited to the terminal stage. Wow. In ETC, one molecule of NADH2 gives rise to 2 ATP. See, humor unlimited, especially after the whole confusion of modern concept. And 1 FADH2 gives rise to 3. So he did reverse, ulta he did, incorrect. Good. You should have confidence now if you are answering correctly. Let me see if there is another question. Did I announce it in the evening? I did, clearly. Guys, if you have not registered for, okay, most of you are 2024 aspirants, I know. But you should share this with your friends, family, neighbors, vendors who serve you, enemies if you have any. Yeah, that Unacademy is conducting the largest scholarship test. Okay, it is going to happen at 11 AM and 5 PM on February the 11th. And you can easily get a smartwatch and laptop, and you can study from any of the favorite educators like me. The Endgame batch is running. The link is given in the description box. This is Endgame 2.0. Yeah, you have this team of fabulous teachers. The most senior teachers of Unacademy platform are teaching you. Yeah, so don't miss this chance. On the same note, I am going to start sexual reproduction in flowering plants tomorrow in the Endgame 2.0 batch. The way I am teaching now, it's absolutely same. If you love it here, you're going to love it even more there. So be a part of my class. I would love to have you. To get the discounted price, you should use the code PM1 live. Dink chicka dink. Okay, time to do. That was such a narrative. Oh, I feel bad for myself. All right, people, real business is here. We are going to talk some real numbers, and this is serious. You know, somebody told the cell that you have to give me ATP. I don't know how you give me energy here. That's all. Now the cell did all of this. He planned, okay, I'll do glycolysis, I'll do Krebs cycle, I will do ETC, so much of hard work. And now he sits on the table and he's asked by the body or by the cell, where are the ATP? So when you calculate the balance sheet, it is different from the energetics of each process that I completely burdened you with, and I'm very happy about it. This is respiration like never before in real sense. But balance sheet is about ATP. We are going to count only ATP formation. Is that very, very clear? Now what you're going to do, we are going to see the various steps. Tell me that what happened in glycolysis. Remember, you are talking only about ATP. How many ATP will be formed? For clarity, I am going to write clearly, we are talking about the net gain. I am not concerned about what happened till today. Tell me how many ATP are formed in glycolysis directly. By substrate level phosphorylation, I get 2 ATP. This was the net gain. Yes. Now, how many NADH2 were formed? 2 NADH2 were formed. 1 NADH2 gives how many ATP? Answers in the chat box. 1 NADH2 gives how many ATP? Yeah? I think I just got 2 years older right now telling only this since evening. Equate, calculate. 1 NADH2, but I am going to keep repeating it, is giving you 3 ATP molecules. In glycolysis, you formed 2 NADH2. Now, if you don't even remember that, then I really have to ask God to do something. I need divine intervention. So, 2 into 3 is 6 ATP, ladies and gentlemen. Don't forget this. He is going to ask the individual gain. He is going to ask how many ATP net gain. If he doesn't use the term net gain, then you have no right. If he doesn't use the word net gain, then you have no right to tell him that 6 ATP are formed. Okay? Net gain means everything is burnt, oxidized. I am going to put a question mark here. There is something wrong here. Not wrong, there is some catch in this story which we will discuss later, just to remind. Next, link reaction. Next is link reaction in the cube. Come on, calculate and tell me how many direct ATPs were formed. I love asking like this. How many direct ATPs were formed here? In link reaction, 2 ATP were formed. Maar do mujhe, maar do. 0. Mayuk, thank you very much. 0 were formed. See, if I have tricked you, I am speaking from examiner's mind. No ATP is formed. But by redox, oxidative phosphorylation, how many are formed? I would frame the question like this. I will say, what is the net gain? How many are formed? Think about it. 2 NADH2. So 6. Once again, I get 6 ATP. Is this clear to everybody? Let's go to the massive gain of energy. The most massive gain of energy happens in the Krebs cycle. Krebs cycle. Tell me how many ATP are formed by SLP. Quick means quick. Or let's change it. How many ATP are formed by, let's do the massive one. How many ATP are formed by oxidative phosphorylation? Quick means quick. Take a while and think about it. I will kill you. This is what. Are you guys real? Are you guys for real? Listen to my question again. Listen to my question again. In Krebs cycle, by oxidative phosphorylation, how many ATP are formed at the end of Krebs cycle? Six NADH2 were formed. 2 FADH2 were formed. 1 NADH2 yields 3 ATP molecules. 18 ATP. 1 FADH2 yields 2 ATP molecules. 4 ATP. What an algorithm we had to use. 18 and 4 is? Okay, no problem. Yeah, now you can give me the correct answer. Why not? After completely breaking my heart into pieces by saying 6. I'm going to write it. Okay, and SLP. Are we all aware of SLP at least? So, 4 ATP and SLP is 2 ATP. Am I absolutely correct? Let's calculate here. What do you get? What do you get? Take out your calculators. 2 and 6. We will follow the tradition first. 8 plus 6 plus 18. ठीक है. 32 तो यही हो गए. This is 32 already. Plus 4 is 36 and 2 38 ATP. Page number 161, second half of the page, last 3 lines. What does it say? Read it out. Page number 161, second half, last 3 lines. 38 ATP. NCERT doesn't consider anything at all. But let's clear out this. Okay? So let's clear out what I have to say. We keep hearing in our life from various people that 36 ATP are also formed. So what is the real deal? If asked without any special mention, please go by the God's voice. It's like a scripture. If NCERT, that's why I am telling you where it is given in NCERT. You will mark 38 ATP. If the question is as simple as how many ATP molecules are formed at the end of aerobic respiration, you are going to mark 38 ATP. Good. So, 38 ATP molecules are formed in liver, kidney and heart cells. Thank God. And also a previous year question, prokaryotes. Whatever can be asked, I have given it to you. Why? Because there is a shuttle system called as the malate shuttle. What is a shuttle system? Alright. So what I am talking about, a shuttle is the vehicle or the carrier for glycolytic NADH2. Once again, since you guys are so engrossed and attentive in this session, in the earlier part of the evening until now, we ascertain that 2 NADH2 molecules are formed in glycolysis. Yes, no, I don't know, I don't care, whatever it is. Something in the chat box. These 2 NADH2 molecules which are in the cytoplasm don't get a direct entry into mitochondrial matrix. More so for the inner membrane where it has to go for its final goodbye, for its final fate, which is oxidative phosphorylation, that is donation of whatever it has. Done? So it needs a vehicle, it needs a shuttle. Which NADH? Glycolytic NADH2. Mitochondrial matrix NADH2 doesn't have a problem. Done? So, this is, ma'am, red color, ma'am, based on glycolytic NADH2 transfer mechanism. If I use malate shuttle, which I use in these cells, then what happens is something interesting. This shuttle will convert NADH2, which is lying in the cytoplasm. Remember, in last birth we studied that glycolysis happens in cytoplasm. Deja vu. Converts it into NAD plus so that it gets entry into mitochondria and is equivalent to the mitochondrial NADH2. As soon as it reaches the mitochondrial matrix taking the bus, it changes into its original form and lies freely and happily in the mitochondrial matrix. Then it can combine with the 6 NADH2 which were formed in Krebs cycle, and now we are okay, we are happy. I have 8 NADH, I have 2 more NADH2. So 10 NADH2 in total is what I have after the shuttle has operated. 2 NADH2 from link, 6 from Krebs cycle, TCA cycle, and 2 from glycolysis. Yeah, out for a 6, ma'am, out for a 6. But what happens in some cases, 36 ATP molecules are formed in nerve and muscle cells. The nerve cells and muscle cells of my body. Why? Because, ma'am, what is happening is, here the bus that he has taken, the shuttle that he has taken, is not so good. All of this I am saying to explain you. It's not actually theoretically not good. It is called as glycerate shuttle. Glycerate aspartate shuttle. This shuttle is very notorious. It changes the cytosolic NADH2 into rather FADH2 when this molecule reaches mitochondrial matrix. So now what is going to happen? Let's go back to the balance sheet. Yeah. Think about it. I was saying, eyes on the screen, that 6 ATP are formed, equating it with 2 NADH2 molecules. In glycolysis, I said 2 into 3 is 6 ATP. But think about it, that if these NADH2, owing to the glycerate shuttle, becomes FADH2, I have a loss of 2 ATP. So, what I am going to fill this space up, since I have clarity now, new fine clarity, I am going to write 4 ATP for glycerate shuttle. So, from now on, this is not an NCERT, but you should know why something is said so popularly. Arey yaar, there you go. So, in this case, what will happen? I am going to get, let's go back. In this case, I am going to get 36 ATP. Very simple. Let's all write it all at one place for clarity. since you all are writing so keenly and attentively. Yeah, you know what, when I can't do anything about something, the sarcasm catches up. Clear means clear. Now I am going to do something more for you. There's a surprise. What do? Let's, because so many videos on YouTube, let's use the modern calculation. Nobody will ask you. Again, your answer is going to be 38, and if he mentions nerve cells and muscle cells of the body, you will answer 36. But let's say, examiner is examiner. You can't place a bet that he is going to act in a certain way only. What if he says, ladies and gents, I make it compulsory to consider that we are following the modern concept, that there are 4 protons required for 1 ATP molecule. If he puts this condition in the question itself, then things are going to change forever. Yes, no? Do you want to do the calculation for that? कुछ तो हो रहा है यार. Got it. Let's do the calculation, yeah. I don't want to leave any stone unturned in your understanding. So if I'm saying that 1 ATP, 1 NADPH, according to the 1 NADH, oh yeah, it's 12, it's time, it's 11 o'clock. If I am saying that 1 NADH2 molecule is giving me 2.5 ATP, then this 6 ATP becomes what? According to that concept, just forget about the shuttle. How many ATP will be formed? 2 into 2.5. 5 ATP. This will change into 5 ATP. Do the maths. If I am saying in link reaction same 5 ATP, yes. If I am saying 18 ATP for 6 NADH2, what if 6 into 2.5 happens? 15 ATP. Shraddha, check the maths here. Mayuk, check the maths. चलेगा ना? 5, 5 और 15 होगा या नहीं होगा? Cool. And FADH2 is making 1.5. So 2 into 1.5 e.g. 3 ATP. This you can't touch. SLP you can't touch. Do the total. Don't forget to add this. Do the total and tell me how much do you get. How much do you get? Oh, you guys have to talk everything but sense. Is it making 32 ATP for you? According to the modern concept? Better should, if I haven't gone wrong. Ashwa, is it calculating to 32? Is it making 32, everybody? ठीक है. So similarly for glycerate shuttle, how much will be formed? 30 ATP. Clear? So according to the new concept, my muscle cells will form 30 ATP. But my heart cells, Dil ka cell, will form more ATP, that is 32 ATP. Let's solve some questions. Let's solve some questions. Where is the... If I have questions... There I go. Okay. Answers in the chat box, everybody. Thank you, real Xavier. The English was absolutely correct. So, how many times decarboxylation occurs during each TCA cycle? Twice? Twice? When and when? When and when? When I form alpha ketoglutaric acid and when I form succinyl coenzyme A. In fact, they are consecutive in nature, successive in nature, aren't they? Thank you. Next question. NEET 2022, everybody means everybody. What is the net gain of ATP when each molecule is converted to 2 molecules of pyruvic acid? The easiest question of the day. Clear or not? I am sitting here to clear your doubts only. There is no other purpose of, I can say, my life right now. Next question, NEET 2020. Those of you who have a routine and follow the circadian rhythm of sleeping on time, please leave the class. I have no pleasure in increasing my live viewers at the cost of your routine. The number of substrate level of phosphorylations in one turn of citric acid cycle. Baba, there is only one substrate level phosphorylation, na? क्या कर रहे हो? Citric acid cycle यार. TCA cycle. How dare you say 4? Vachan Jain, if you will come to my class like it's the garden next to your house just to take a walk, it will never be clear. I'm not selling bananas here. Is this clear to everybody? I'm sorry, I'm rude, but you can't just come to my class walking anytime and tell me in such a super technical chapter that you're not getting it. ठीक है. Congratulations. The hard and the technical part of respiration is done. At least I want to congratulate myself. Chalo. Now let's get to the conceptual part. It would be really lovely if citric acid cycle, glycolysis and ETC are more clear to you than ever before. I mean, it would really help you. Forget about mine. So now the concept in the beginning of the class, when we define respiration, I told you very specifically that in traditional sense, because we see, what is evident is that there is breaking of complex carbohydrate, complex molecule, glucose into simpler inorganic substances, that is carbon dioxide and water. We call it a catabolic, exergonic, all of that. But in real sense, it is a amphibolic pathway. So let's get the evidence out of it. We are not going to mug up anything. Although in NCERT it is not explained evidently, but for better sleep, for my own sleep, I am going to prove it. And it will help with better retention of the concept. So, the most favored substrate amphibolic pathway is based on the fact that at any given point of time, I am not eating only carbohydrates. I am not eating only the substrate with which I start my glycolysis or even Krebs cycle. It is not only carbohydrate based. It can be fat also, it can be proteins also, it can be organic acid also. Yes? So, we are going to, but the most favorite one or the favored one by the cell is glucose because it's traditional. Okay? So, we are going to keep it in the center. Fine, you give me glucose, I am happy. I do what I do, and ultimately what I do is I take acetyl coenzyme A following all the processes, and I was making citric acid. From citric acid, in the evening I formed alpha ketoglutaric acid. That time also I told you it is the, and that is a question, it is the most important intermediate compound. Boys and girls, whatever you have studied about respiration till now, and NCERT mentions it, is not the truth. It is the truth, but it is not happening in such a sequential or a unidirectional mode as you have studied it. Oh, properly, glucose, glycolysis will happen, then acetyl coenzyme A will be formed, then Krebs cycle will happen. More often than not, the reactions don't proceed this way in case of respiration, and more often than not you don't even get 30 ATP. Why? We'll see. This alpha ketoglutaric acid changed into, can you help me out here? Succinyl coenzyme A. Succinyl coenzyme A. Okay, and this acetyl coenzyme A had actually combined with OAA. It has actually combined with OAA. I am missing out on the intermediate steps because my area of interest right now is this. But what if on a certain day I am using fats? क्या ही करेंगे? I am using fats as the respiratory substrate. What will you do? The fats will have to be hydrolyzed. I need extra energy. That's why these days people are doing high fat diet to lose weight. So fats will be hydrolyzed. Lipases will come in action. Hydrolyzed. Yeah. See, this is what happens in marathons. I will get fatty acids. This we know from digestion. Ma'am, not in the syllabus, ma'am. Yes? As the fate would have it, fatty acids are converted by beta oxidation into acetyl coenzyme A. Do you see what I did? Do you see what I did? This reaction is a double-sided reaction. This means that cell is not thinking like you are thinking. Oh, I want acetyl coenzyme A, chahiye hi chahiye. Come on, all the fatty acids get going, convert into acetyl coenzyme A. so that Krebs cycle can continue. Anywho, let's keep going as it is. Glycerol changes into 3-phosphoglyceraldehyde. By some oxidation and some phosphorylation to happen. And this 3-phosphoglyceraldehyde will directly go further into the glycolysis part. Very happy. Cool. Now, this acetyl coenzyme A, which you form with the help of glucose, can be snatched away by any given day if the cell requires more fatty acids, more fats to be formed in the body. I can give you the example in case of plants. What if a plant has a fatty seed? It's a groundnut seed. Okay? And the seed is preparing itself, taking care of embryo. Embryo is growing. I need a lot of fatty acids. That's the nature of the seed. That's the nature of my nutrition. Acetyl coenzyme A would not be able to go further. So, if you are saying that fats are broken down into fatty acids to form acetyl coenzyme A, mind you that the other way is also true. The other side of the story also holds true. This can also happen. Let's just write it this way. Not only this, the acetyl coenzyme A is also the precursor for which plant growth hormone? Come on. If you have studied from me, you should be able to answer this. Which plant growth hormone forms, which plant growth hormone is formed by acetyl coenzyme A? Fast means fast. Gibberellic acid. So, while Krebs cycle, while Shraddha was sitting and thinking, wow, acetyl coenzyme A aa gaya. Now Krebs cycle will continue. In reality, any of these compounds can be taken away from the scheme of Krebs cycle to synthesize, listen to every word carefully, to form something more complex. While these intermediate compounds of the mighty Krebs cycle function as just precursors. So maybe the Krebs cycle won't happen. You see, synthesis is happening. Acetyl coenzyme A also forms the phytol chain of chlorophyll, which we did in the last class, and that is why I taught you the structure. It also forms carotenoids, if you were thinking any less. The accessory pigments, without carotenoids, my chlorophyll will burn away. You see, come to citric acid now. Come to citric acid. Come to alpha ketoglutaric acid. Alpha ketoglutaric acid will form proteins, will form amino acids. And to explain you that, let me tell you, suppose the cell has got a very rich, what all other things people do to lose weight? Let's eat a protein rich diet. And that is cool. Proteins will be hydrolyzed by proteases into amino acids. Am I right about that? Let's say I got glutamate. This glutamate will convert itself into alpha ketoglutaric acid. okay, by transamination, by removal of the amine group, transamine, that's your chemistry. But guys, if my body needs a lot of proteins, if my cell needs a lot of proteins, then this would also happen. The alpha ketoglutaric acid will be snatched away from the Krebs cycle. And the seriousness of the situation is that the energy that you were making, no, ATP, NADH2, you were thinking, oh, I'll get 38 ATP. That energy can further be utilized to form your secondary metabolite or primary metabolite. Cool? One more thing can also happen. Alpha ketoglutaric acid will form proteins, okay? Amino acids will form proteins. This happens very much in the cellular respiration. Come to succinyl coenzyme A. In fact, sometimes glycine, which is I think a non-essential amino acid, if I am not wrong. You study that in chemistry, yaar. Bolo, glycine is non-essential, right? Glycine will form oxaloacetic acid. So, if the cell has got a lot of protein, it can break down into, it will break down into several amino acids. Glycine will give rise to oxaloacetic acid, and glutamine will give rise, glutamic acid will give rise to done. Now let's talk about succinyl coenzyme A. Succinyl coenzyme A is taken away, is snatched by the plant to form chlorophyll. Very, very important. And if you don't know, all the cytochromes that you studied in the evening, cytochrome C, cytochrome A, cytochrome A3, precursor is succinyl coenzyme A. This was just to show you that respiration is not as simple or direct as it looks like. Okay. So, what is actually happening, that intermediate substrates of respiration are utilized for synthesis, and synthesis in true sense is anabolism of primary or secondary metabolites. I am writing this so that your AR is taken care of. Hence it is called as, therefore it is amphibolic. And this is the reason and you know what, if I am making something, what if alpha ketoglutaric acid wants to make proteins? I would require energy, and that is why the cell planned. This is the reason this further derives the concept of multiple steps, because if you released all the energy in one go and the body is like, hey, give me carotenoids, form chlorophyll for me, form proteins for me, and then you don't have energy. So cell is very intelligent. We are not. Multiple steps or controlled release of energy, boys and girls. With the last ounce of voice left in my vocal cords, let's also do anaerobic respiration, which is nothing but popularly called as the, what is it called as? Fermentation, right? So I know for a fact that everything is happening in the absence of oxygen. If there is absence of oxygen, it means that there will be incomplete breakdown of respiratory substrate, be it fat, be it glucose, be it protein. But certain things remain the same. Since it is a cellular process, it is going to be enzymatic, it is going to be controlled, it is going to give you energy much less, in fact 2 ATP molecules. Okay, enzymatic, controlled, exergonic. The keyword incomplete is a better term. Incomplete breakdown of respiratory substrate in absence of oxygen. In absence of oxygen. Very interesting thing happens. The products, the nature of the products in aerobic respiration was inorganic end products. CO2 and water were formed. Here, since there is incomplete or partial breakdown, nowhere I am using the term oxidative, which I liberally used for aerobic respiration. The end products are organic and inorganic both. Glycolysis happens. Glycolysis in cytoplasm will happen to give ATP, NADH2 and pyruvic acid. This pyruvic acid decides to enter a pathway which does not involve oxygen. This kind of pathway is seen in bacteria, some bacteria, yeast, unicellular eukaryote, unicellular fungus, ascomycetes if you will, muscle cells, our muscle cells. Now depending on the end substrate, depending on what is formed here, I have two types. In general, it is called as fermentation. Yes? Tell me in the chat box, this is all chemistry here. You have the lactic acid fermentation and you have the ethyl alcohol fermentation. As simple as that. Baba, in one case I am making lactic acid, in another case I am making ethyl alcohol. So, what happens in lactic acid fermentation? Lactic acid fermentation. Good. Well, I will start with pyruvic acid. And in a single step, I change it. This is seen in lactobacillus, LAB bacteria. Your dairy industry or everyday curd formation is based on this, isn't it? And muscle cells, whenever we do any activity, physical activity, you know, you go for a run, you work out, you go to the gym, you have a certain muscle ache. That is because of accumulation of lactic acid. But if it remains accumulated, we will land in the hospital because it is toxic. So this lactic acid, which will be formed from pyruvic acid, I am going to use NADH, which was formed. See, energy is getting used, not so cool. Whatever I formed in glycolysis, and I am going to use lactic acid dehydrogenase. Lactic acid dehydrogenase, and I will form lactic acid plus NAD plus. This is about it. Alcohol will not be formed. Now boys and girls, this lactic acid has to be sent to liver. The liver will convert it to form glucose. If it is not sent there, sent to liver. Liver is the most hard-working organ of our body. Everything that is formed in your body is metabolized by liver. It has to go through liver. Liver will form glucose out of it, and that glucose can enter the glycolytic pathway to derive energy. Although it is zoology, what do you call this process? When liver is formed, when glucose is formed from a non-carbohydrate source, what do you call it? Don't tell me, ma'am, it's not in the syllabus. Why are you asking? Okay. Also, our heart cells. Do you know when we do some really strenuous exercise, when you're running, when you're working out, your heart cells are pumping blood at a greater rate. You walk on a treadmill, you walk on a cycle. It tells you about your heart rate. Your heart rate, if it doesn't increase, you will not be able to work out. Because your heart has the LDH. This is called as the pyruvate lactate axis. Your heart muscles convert lactic acid then again into pyruvic acid to derive energy. This pyruvic acid reverse reaction will happen, will quickly go into the Krebs cycle, and lot of energy by aerobic respiration will be formed. If it doesn't happen, heart failure happens. Have you heard about people having a heart attack while working out, while running, or these days it's happening a lot? Or, you know, this, I don't think it is in your cardiovascular system. All you read about is myocardial infarction. Myocardial infarction is very different from heart failure. Heart failure is a chronic disease. In such patients, you will find out that there is hypertrophy of the heart muscle. It has grown, it is increased in size. It has to pump, it has to work harder. That is called muscular hypertrophy. Why? Because this axis was disturbed and you were working, taking out so much of work from the heart muscle. So even in cardiovascular system, this question is important. Myocardial infarction, it's zoology, I know, but you know, this reminds me of my first year of college. We used to study in physiology. It's pretty interesting. Maybe one day I'll take a class on cardiovascular system, one of my favorites. So, you will always find cardiac hypertrophy in heart failure patients. Myocardial infarction is happening owing to atherosclerosis. There is blockage of the arteries. So, heart failure is usually owing to one of the reasons is this. This finds significance in dairy industry. Why? Because when you set the curd, what is happening is lactic acid is coagulating the casein protein of milk. And you get curd, or you can make paneer and cottage cheese. Yummy. Cool? This much you can do. So I gained 2 ATP of glycolysis. I am happy. Pyruvic acid, 2 molecules. So everything is 2 here. Needless to tell you. The second one is the mighty ethyl alcohol, or simply alcoholic fermentation. Now that is very commercially used. अरे खेलता है. Alcoholic fermentation. This is the second last topic. Please don't be tired. My battery is full. I just put the switch on. This will be seen in yeast and where will it be seen? Yeast. That's it. And it finds its significance in brewing industry, alcohol industry and baking industry. Why? Because here pyruvic acid changes into, with the help of pyruvate decarboxylase. Decarboxylase enzyme tells you what? There is removal of carbon dioxide. Let's remove it. Who cares? 3 carbon compound, na? So, I am going to form acetaldehyde. Let's not take shortcuts ever. Plus carbon dioxide. Okay. This carbon dioxide helps in the baking part. You know, the cake rises up. Yummy, yummy. And fermented beverages. But that's not about it. That's not how I can make alcohol. So for alcohol, I use the second reaction. Acetaldehyde is acted upon by alcohol dehydrogenase. And here I am going to reduce the reduction power of NADH. See, again I have used by energy. And I form ethyl alcohol here. This ethyl alcohol accumulates. You know, even if lactic acid accumulates in my muscles, it's poison. So anaerobic respiration is not seen in higher animals. Even in yeast, your NCERT says this. If alcohol concentration exceeds 13%, then yeast will die. Okay? Plus NAD plus will be formed. Okay? Let's write everything. If more than 30%, yeast dies. How do they increase the alcohol concentration? By distillation. That's why they have distilleries. Cool? Let's see what do we have in future. We have a question. Come on. Don't tell me to move away. This time I remembered. Tell me the answer. I have the question in front of me. Fatty acids are connected with the respiratory pathway through what? Everybody is sure? Fatty acids are connected with the respiratory pathway through acetyl coenzyme A. Say thank you for telling you that. What amount of energy is released from glucose during lactic acid fermentation? I forgot to tell you, it is less than 7%. From 1 mole of glucose, if I am forming molecule or mole, something like that, 300 some kilocalories, here I will be forming some 49 calories. Very, very less energy, because you see Krebs is not happening, ETC is not happening. What is the source of energy? Only glycolysis. What do I do? Okay. Last topic of the class. Trust me, I am so sleepy. My sleepy is sleepy. But I am not sleepy for the class. Okay? Respiratory quotient. This is based on the fact, oh, 2 pens in my pocket. Respiratory quotient is based on the fact, on the realization that respiratory substrate can be anything. Anything doesn't mean just anything, you know what I mean. Okay. So now we are going to keep it very simple. The most favored respiratory substrate is what? Very quick in the chat box. Bol do. Finally, last topic. Yeah, I should say that. Tell me fast. Come on. Even if it is last, even if whatever the glucose. Okay. Glucose. Think about it. First of all, let's define respiratory quotient. Yaar. What is respiratory quotient? It is the ratio of volume of carbon dioxide evolved to the volume of oxygen used. Can we do that? How much oxygen I have used? How much carbon dioxide I have evolved? The ratio is called as the quotient. Now, what I was saying, if I consider glucose, what do you think? You know this. I don't have to tell you anything here. Come on. Volume of carbon dioxide evolved. Look at the equation. Yes, so it's coming out to be 1. Very happy. That's why glucose are good source of energy. What if I am using fats? It will be less than 1, or let's be very specific, it will be 0.7. This means more volume of oxygen is used. This means I have to breathe in more oxygen. Your NCERT gives the example of tripalmitine in the last page, 164, something like that. Open it up. Tripalmitine, and it shows 145 kilocalorie of, 145 molecules of, 145 molecules of, pardon me, it's 12 o'clock. (145 molecules of O2 used and 102 molecules of carbon dioxide evolved. He can give you the equation directly and ask you, tell me, what am I talking about? So you will say, yes, we know we are talking about 0.7 and the respiratory substrate being fats. This has happened in the past. Cool. Now if I talk about proteins, it is 0.9. Again, slightly more, but volume of O2 used is more. Can you remember that? None of these are my favorite questions, you know. but I am going to give you one more. Now what I am going to ask you is not in NCERT, but they are extremely lovely questions which can be asked in the exam. This is that 5% of NCERT which you have to go outside, at least if you are associated with me, because I have to keep you safe. Now let's add one more here. Can we do that? And what you will realize is, I will ask you the questions and you will use your common sense and answer. There is nothing difficult. If you use organic acids, your respiratory quotient is going to be more than 1. Volume of CO2 is evolved more because organic acids have more carbon. What is interesting to note is that at any given point of time, usually your cells have more than one RQ on any given day, Monday to Tuesday to Wednesday to Thursday. Why? I am never using only glucose as the respiratory substrate for my cell. Common sense. Isn't it? I am using a mix. I am using a mix. So it has to be more than one. Now let's get to the interesting part here. Tell me, I ask you, can you see this part of the board? Question number 1. When is RQ equal to 0? बताओ, बता दो. When is RQ equal to 0? In order for RQ to be 0, this has to be 0, numerator has to be 0. When is it 0? Thank you. Thank you. Thank you. Amazing. Congratulations to who all answered. You're quite well informed. This is the case of succulent plants or where CAM pathway operates. What is CAM pathway? It is crassulacean acid metabolism. Was discovered in Crassulaceae family, xerophytic adaptation, scotoactive stomata, blah, 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 all gone out of the window. I can see the quietness. Okay, let's make it simple for you. Forget about although you should know that. Well, in crassulacean acid metabolism, let me remind you or inform you that stomata open at night and carbon dioxide is not really evolved. Carbon dioxide is fixed in the night. If you have studied C4 pathway with someone called as Pankhuri ma'am 15 days ago, I spoke to you about pepcase activity. Yes, no, last birth, we don't know anything ma'am, it's okay, you can be honest. So pepcase, phosphoenol pyruvate, combines with carbon dioxide. He is the initial fixator and forms the 4-carbon OAA. It was doing that in the mesophyll cells. We isolated Rubisco enzyme spatially. We said you are notorious, you are combining with oxygen, yeah, you are ditching carbon dioxide, so go away. I am going to lock you up in the bundle sheath cells. In these plants, I am scared about transpiration. I'm cactus, I'm opuntia, I'm kalanchoe. These are all succulent plants, xerophytic plants. They can't afford to open their stomata during the day. All the water will dry up. So they said, let's create a periodic isolation, periodic arrangement, wherein the carbon dioxide fixation will happen in the night. The stomata will open, carbon dioxide will come in, I will form malic acid. I hope you remember, I pray you remember, that oxaloacetic acid was converted into malic acid. Then malic acid is transported to the bundle sheath cell through plasmodesmata. There it gets converted. There it goes decarboxylation. And that carbon dioxide is used up for final fixation by RUBP. Rubisco does that. Now in these plants, that happens during the day, no problem. But I am not opening the stomata, I am not evolving any carbon dioxide, I am using the carbon dioxide during the day when malic acid will undergo decarboxylation. If none of this makes sense to you, just remember that in these plants, no carbon dioxide evolution takes place. Hence, RQ is 0. Second question. Second question on the plate. This is more my favorite than anything else. How is RQ infinite? Who will be my darling and keep my heart alive? Come on. How will you make RQ infinite? You will have to make denominator 0. That is, no oxygen is used. Oh God, I gave you the clue. Damn it. Shouldn't have. But bolo bhai. Yeah, I mean, this was supposed to be a short chapter. Anaerobic respiration. Very good. Anybody who has a problem in this, anaerobic respiration. If you felt that you have never studied ETC like this ever, since you all are droppers, put it in the comment section after the class. Okay? Another question? I think no. These were the questions. So you have all the scenarios: 1, 0.7, 0.9, less than 1, more than 1, 0 and infinite. हो गया. Last question. I am moving. Respiratory quotient value of tripalmitin, which is a fatty acid. Quick means quick. Quick means quick. Clear? Easy means easy. Is there a next question? No. This was the last question. Cool? And boys and girls, so let me see what you comment. Respiration is done and dusted. Killed it. Now, one thing is for sure, you will have to revisit the session. The real killing will be if you kill it in the main exam on 5th of May. All of this hard work is happening so that you kill it on 5th of May. I'm telling you, revisit ETC, Revisit Krebs cycle again and again on an increased speed, 1.25, 1.5. In my case, you can go up to 1.5 easily. And make sure that you kill these topics. Okay? Tomorrow, Endgame students, I'll see you. I'll update the time. Tomorrow afternoon. If the class is not happening at 4 or 5, it will happen later. But it will happen. We'll start with sexual reproduction in flowering plants. People who are not a part of the Endgame batch, you can still click on the link in the description box and pinned in the comments and be a part of it and meet me every day. Chalo. Thank you so much, guys. Lots of love to you. Lots of good health and wisdom to you. Never feel demotivated. It's just an exam. Yeah? After all, it is just an exam. It's not your life. Whenever you feel demotivated, come to me. Yeah, I will have a sound sleep. I'm up since early morning. Chalo. Thank you. Keep smiling no matter what. And I'll see you when I'll see you. That's tomorrow. The bracket said I'm done. So F1, F0 particles have fallen down and so the curtains fall down.